Hello and welcome to this ultimate home automation course using Arduino Uno board. Throughout the course, we are going to learn how to create smart gadgets using Arduino Uno and integrate it with our Python code. We are going to create not one or two smart gadgets but 25 plus smart gadgets throughout the course. It will be totally practical and hands-on experience throughout the course, and you will learn everything from very basics to an advanced level by building different smart gadgets throughout the course with the help of our Arduino Uno board. You will learn how to control your normal devices and appliances using sensors, computer or laptop, Telegeram bot, and at last but not the least using Jarvis AI assistant with voice command. And the end result of this course will be the ultimate home automation that we will be able to create by converting our normal devices or appliances into smart devices and integrating them with IoT, using which we will be able to control our devices with the help of the Internet of Things. So now you don't need to spend money on expensive smart devices. With the help of this course, you will learn how to create your own smart devices. I am Arbaz Khan and I will be your instructor throughout the course. I have more than 5 years of experience in Python, IoT and robotics, and I have built over 500 plus projects with the help of them. I am teaching on Udemy from last 2 years, and in the span of 2 years, I have 2 bestseller courses on the platform, and I hope you will be learning a lot from this course. And let me show you the end result of this course by introducing you to the Jarvis AI assistant.
Hello, I'm Jarvis 2.0, an advanced artificial intelligence assistant developed using Python programming language, machine learning, natural language processing and neural networks, integrated with IoT and robotics. Created by Arbaz Khan. In this course you are going to learn to create an advanced artificial intelligence assistant using Python programming, machine learning and natural language processing. Let me show you some of my features that I'm capable of.
Hello Jarvis.
Hello sir, Jarvis at your service. Please tell me, how can I help you?
Jarvis, initiate the drone in selfie mode.
Okay sir, initiating drone in selfie mode.
Allow me to introduce myself. I am Jarvis, a virtual artificial intelligence, and I'm here to assist you with a variety of tasks as best I can, 24 hours a day, 7 days a week. Importing all preferences from home interface. Systems are now fully operational.
Jarvis, turn on lamp.
Okay sir, turning on lamp.
Jarvis, turn off lamp.
Okay sir, turning off lamp.
Jarvis, turn on the AC.
Okay sir, turning on the AC with temperature 20 degrees Celsius.
Turn on the lights, Jarvis.
Okay sir, turning on the lights.
Turn off lights, Jarvis.
Okay sir, turning off the lights.
Jarvis, turn on the wipers.
Okay sir, turning on the wiper.
Jarvis, open the left window.
Okay, sir, opening the left window.
Jarvis, close the left window.
Okay, sir, closing the left window.
Jarvis, play some songs.
Okay, sir, opening the playlist.
Jarvis, how is the weather?
Sir, the temperature in the car is 25 degrees Celsius.
Jarvis, how much fuel do I have?
Sir, the fuel is around 12 liters. We can go 171 kilometers now.
I hope you liked it what you saw. Then what are you waiting? Click on that enroll button now and get started with the course to create your own advanced personalized AI assistant. Okay, I need to go. Mr. Khan is back. Love you 3000.
In this video of the course, we are going to be discussing about all the hardware components that are required for this ultimate home automation course using Arduino Uno board, and a PDF format of all these components is available to download in the description or the resources section of this video. So you can go there and download that PDF file. You will find all the images of the components that we are using, as well as the appropriate serial number and name of that component that we are using in this course. And you can also find the Amazon link using which you can refer that exact product and try to purchase it by visiting that link. So if you have any issues or doubts regarding the components, so you can just leave it in the Q&A session and I will try to help you out with that as soon as possible. So first of all, we are going to be needing an Arduino Uno board. So you can see on the screen, this is the Arduino Uno board that we are going to be using throughout the course to control all the hardware components with the help of this microcontroller. And you can see it has multiple pins on it, and you can see there are in total 13 digital pins on this Arduino Uno, as well as there are 6 analog pins on this Arduino board. And there is also some ports using which we can connect the power as well as ground with this Arduino board. So let me keep it aside. After the Arduino board, we also need a breadboard. So you can see this is the breadboard which we are going to be using, and using this we can extend the connection from our Arduino board onto this breadboard and connect the multiple pins with single input which is coming from our Arduino board. So for example, you can see that there is only one 5V on the Arduino board. So if you want to extend that, we can extend using this breadboard. So this is also very important, and it will make our process of creating circuits very easy with the help of this breadboard. So I will just keep it aside. And after that, we are going to be needing some jumper wires. So you can see these are the jumper wires that we are going to be needing, and mostly we need male to male and male to female jumper wires. So I will recommend you to get an entire combo of this jumper wires and the breadboard, and you can find that on Amazon easily, and the combo is very cheap. So you will get all these jumper cables and the breadboard. And one of the most important component, that will be our relay module, using which we are going to be controlling all the hardware components that will be connected to our relay module. So using it, we are going to be controlling all the hardware components like light, fan and other devices using it with the help of this relay module and the Arduino board. So this is a 5V relay. You can find it easily on Amazon, and you can see it is a 4-channel relay, so you can connect up to 4 devices. There are different configuration of this relay module. It comes up to 32 relays on a single board, and you can get a 32 relay module and control up to 32 devices using the Arduino board. So let me put it aside. After the relay module, the next component that we are going to be needing will be a bulb holder like this. You can see this is a bulb holder using which we can connect this bulb with a holder, and we can connect 2 wires with it, and these 2 wires can be connected to our relay module. So this is a very simple bulb holder that you can find in any electrical shop. So I'll just keep it aside. After that, we are also going to be needing a bulb. So this is the bulb which I am going to be using. This is a 9V bulb that we are going to be connecting with this bulb holder and trying to control in our course. So I will just keep that aside. Another component that we are going to be needing will be a 2-way switch. So using this, we can control the relay module with the help of this 2-way switch. So basically, we are going to be connecting this bulb with this relay module as well as this two-way switch. So it will be also able to control through the two-way switch and also the relay module. So this is also required. So let me put it aside. So the other component that we are going to be needing will be a socket. You can see this is the socket that we are going to be using, and we are going to be converting it into a smart socket in our course. So that's why we're going to be needing this socket, and we will be able to control the devices that are connected to this socket using our Arduino board. So let me put it aside. We are also going to be needing this LEDs. So you can see these are multicolor LEDs like red and green. So we are going to be needing that as well. So we are going to be also trying to blink these LEDs and control them with the help of our Arduino in our basics. So you can get multiple color LEDs. I will recommend you to get around 5 to 10 LEDs of this kind. You can see that they have two inputs, 5 volt and ground. So I will just put it aside. We are also going to be needing a LDR sensor. So you can see on the screen, this is the LDR sensor. So you can see on the screen, this is the LDR sensor, which I am talking about. So you can find the links in the PDF as well. So I will just keep it aside. Also for connecting this LDR sensor, we are also going to be requiring some resistors. So you can just check out the PDF for the details about this register. And after that, we are also going to be needing a addressable RGB LED strip. So you can see this is the addressable RGB LED strip that I'm going to be using. You can find it on Amazon easily, and the details about it is given in the PDF. So you can just go there, and you can see there are in total 3 pins on this LED strip. The first one is 5 volt, the middle one is the digital pin, and the third one is the ground. So using this addressable RGB strip, we are going to be controlling it with our Arduino board. So let me put it aside. And after that, we're going to be needing some sensors. So this one is the ultrasonic sensor, using which we can calculate the distance. And also we're going to be needing a PIR sensor, which stands for passive infrared sensor. So using it, we can sense the motion with the help of this sensor. So you can see there are in total 3 pins on it as well. And the last component that we're going to be needing will be a temperature sensor, using which we can get the temperature as well as the humidity of the room with the help of this THT11 sensor. And you can find all the links as well as the references to all these components in the PDF that is available in the resources section of this video. So you can just go there and try to get all these components with you. And also you're going to be needing some wires with this kind of plugs. So you can find out the appropriate plug for your country and just purchase them. And you are also going to be needing some wires to connect with this plug, and we are going to be powering up all the components using this wires and connectors. So you can just purchase them according to your country. So these were all the hardware components that are required for this course. So I will recommend you to purchase all these components first and then start with the course, because if you don't have any of this component, you won't be able to complete the entire course. So I will recommend you to get all these components by going on to Amazon or eBay and purchasing all these components as soon as possible. And once you receive the components, you can start with the course. And if you have any doubts or issues related to any of the components, so you can just leave them in the Q&A session of the course, and I will try to help you out with that. So that was it for this component introduction video. Let's move to the next video of this course. In this video, we will take a look at Python in under 120 seconds. Let's get started with it. Python is a high-level interpreted multi-purpose programming language. It is one of the most popular programming language in the world because of its beginner-friendly syntax and ease of use. In fact, you are watching this video on a Python web application. It was created by Kudo and Rawson and released in year 1991. It is widely used in server-side applications using Django framework. Aside from Django, Flask is also used for small projects, and it is a language of choice for artificial intelligence, machine learning, and data science. It can be also used as an scripting language as well as for automation. By the way, a course on ultimate automation using Python is coming up soon, so stay tuned for that. Many students choose Python to start learning to code because of its readability and simple syntax similar to English language. The most recent version of Python is Python 3. Also, there is another version which is Python 2, although it's not being updated anymore. So there might be a question in your mind that why should you learn Python? Tech giants like Google, Facebook, Instagram, Netflix are using Python for development and hiring for Python developers. And the salary of a Python developer ranges between 80,000 US dollars and goes up to 110,000 US dollars. So isn't it exciting? Let's try comparing Python with other programming languages. C uses 5 lines of code to print hello world. C++ uses 6 lines of code to print hello world, and Java uses 7 lines of code to print just hello world. But Python only uses 1 line of code by just typing print, and we also don't need to compile the code. We can directly run the code with the help of the interpreter. So if you are interested in learning Python with practical and hands-on experience, I will be leaving some links in the description of this video so you can check it out. And that was it for the Python in under 120 seconds, and I tried to give you a brief overview of Python, and that was it for the video. I will see you in the next one. So in this video of the course, we are going to be setting up our development environment for our course. So for that, we need to install Python and VS Code onto our system. So for that, I will just open an browser and I will just search for Python on Google, and you will find this first result that will be python.org website. So we will click on this first link and it will redirect us to this website, which is python.org, and this is the official website of Python, and you can find all the documentation as well as the latest version of Python. You can download the exe file or any other files that are required, and you can also find the documentation for the Python as well. So on this website, we will hover over this download section and we're going to be downloading this latest version of Python on our system. So we will just click on it and it will start downloading it on our system. So once the download is finished, we're going to be installing it on our system. And the another piece of software that is required is called VS Code. So I will just type here VS Code and we will search for it, and you will get the first result as download Visual Studio Code. We will click on it and we're going to be downloading it for our Windows system. It is available for Linux as well as Mac, so you can download the appropriate version for your system. So I'm using Windows system, so I will just click on download and it will start downloading this VS Code onto my system, and we will go on to this website. So basically the Visual Studio Code is a code editor that has an inbuilt functionality of running the code of different programming languages, and it supports different extension as well for different programming languages. So for example, if you're working with different programming languages like Python, C++, or any other language, so it has the support for Visual Studio Code using the extensions that it has in the extension market. You can just download it and they are totally for free. So it is really helpful for developers to work on different programming languages through a single code editor or IDE. So once these both softwares are downloaded, we will go in the Explorer and we're going to be installing these both software one by one. So first of all, we will install the Python. So for installing Python, we will just double click on this exe file and we will see these options are there, and we just need to check this box which says add Python 3.9 to path. Otherwise it will show errors while you are running the Python code and it will not recognize Python as an command. So you just need to select this box, otherwise it will give you errors. And once that is done, we are going to be clicking on customize installation and it will take you to the next page and it shows optional features, and we will not change anything here. We will click on next, and in advanced option we are going to be selecting install for all users. So if you have multiple users on your system, so it will install it for all users, so you can use Python for them as well. So once that is done, we will click on install and it will ask for administrator permissions. We will click on yes and it will start installing it on our system. So it will take few minutes to install it on our system, and once that is done, we will just open the CMD and we will try to run the Python command and see if the Python is successfully installed on our system or not. So it is installing this packages and documentation of Python on our system. It will take only few seconds for me because I have an SSD installed on my system. If you are using an HDD drive or an hard drive, it will take longer time for you, and I will recommend you to use SSD for your software development purposes, as it speeds up the process of installing and doing other things on your system. So let it get installed. I will be back once the installation process is finished. So finally the setup is completed. It took me like 1 minute to install this Python on my system, and you can see setup was successful. And we will just click on this close button, and to check whether the Python is successfully installed or not, we will just click on this address bar and we will just type here cmd, and it will open the command prompt inside this folder, and we will just type here Python to see whether Python is successfully installed or not. So you can see Python 3.9.4 is available on our system. So we can try printing out something. We will try print, and we can print out testing Python 3.9, and if I hit enter, so it will print out this line for us. So it means the Python is successfully installed on our system. So we will just exit out of this Python interpreter, and after that we will just go back and we are going to be installing the VS Code IDE onto our system. So I will just double click on this exe file of VS Code, and I will just click on accept. I accept the agreement. I will just click on next. I will select this create a desktop icon, and I will click on next, and it will ask me to install. I will just click on install, and it will start installing this piece of software on my system. And once that is installed, we can just right click, and we will be able to see this option of open with code. If I just click on it, so it will open a Visual Studio Code window inside that folder, which is our Python folder. And you can see if you want to create a new file or something like that, so just need to click on a new file, and we can just save it with a Python extension. But before that, we need to install the extension for the Python. So for that, I will just click on this extensions, and here we will just type Python, and you will get this first result of the Python extension. So I have already installed it on my system. You just need to click on install, and it will start installing it on your system. And once that is done, we can start writing the code for Python on our system. So I will just close all these things, and I will just try to create a new file with the name test.py, and inside that file I will just write a print statement. So I will just try to print out something using this file and check whether the Python is working properly or not. So I will just type here hello world, and you can see that it is asking me to select the Python interpreter which I want to use. So I have installed multiple Python version on my system, so I have 2 versions of Python installed. So if you have only one version of Python, it will ask you to select that. So I will just select the recent version that we have installed, which is Python 3.9.4, and after selecting that, it is now selected, you can see here. And I will just try to minimize this thing, and I will just zoom in a little bit, and I will just close this thing. And if I just click on this run button, so it will start running the code for us, and you can see hello world is printed out on our terminal. So it means the Python is successfully installed on our system. So that was it for setting up our development environment, and we have installed Python as well as the VS Code successfully. So without further ado, let's move to the next video of this course. So in this video, we are going to install the Arduino IDE software on our system. So for that, we are going to search on Google Arduino IDE. And after searching on Google, we will find the first result, which will be Arduino software IDE. So we are going to click over it, and we are going to scroll down, and you will see the download page for this Arduino IDE software. So we will be installing it on our Windows system. So we will click on the first link, which will be Windows installer for Windows 7 and up, and it will redirect to this page, which will be a contribution page for the Arduino community. So if you are interested in contributing this to this Arduino software, so you can also contribute them by clicking contribute and download. So you have to pay some amount and contribute to this Arduino software, but we are going to just click on just download, and we are going to download it for free. So after clicking it, so it will start downloading on our system. So I have already downloaded it on my system. So after downloading, we will click on the installer, and it will open up this page which will be license agreement. So we will click on I agree, and we are going to click on next, and it will install it on our system. So it will take some time for installing it on our system. So basically this Arduino software will be using C and C++ code. It will be a combination of both of these, and we can't use the Python with this Arduino Uno board, but we will be trying to control this Arduino Uno board with our Python code using our Jarvis AI assistant. So it will be a really cool thing that we can control this Arduino Uno board with our Python code. So in the end of this session, we are going to learn how we can control this C and C++ code with our Arduino. So it is asking me to install the drivers. So I will install all the drivers it is asking for. So I will just click on install. So it will install all the drivers for me. And it has completely installed on my system. So I will just click on close. And after clicking on close, I will just minimize this, and as you can see, I have got the executable file of this Arduino Uno board. So let me just open the IDE for this Arduino IDE, and it is typing the IDE for us. And we are going to click allow access, and we have successfully installed the IDE on our system. So let me give you a brief overview of this IDE. So first of all, you can see there is a pre-built sketch which the Arduino IDE gives us when we start a new program. So you can see there is a void setup and a void loop. So the void setup is basically the code which you want to run only once while the program starts, and the loop is like when you want to run the code repeatedly, like you want to implement for or while loop. So you can use this while void loop part for that, and you can use to define the pins, you can use the void setup part, and there are different options on this board. So let me show you the different options on this IDE. So first of all, you can see there are file, edit, sketch. So you can in the sketch part, you can see there is a verify and compile part, and there is a upload part. So using the verify and compile, you can compile the program, and if you click on this upload button, so it will upload the code to our Arduino board after connecting it with our computer. So there is another option which is tools. So you can see there are different options available here like serial port and Arduino board. So we are going to be using Arduino Uno, so it has already selected the Arduino Uno board. And so after connecting the Arduino Uno board, we will get this port also. So we need to select the port which we are connected with on our computer. So that was a little brief overview of this IDE. So let's move into the next video, and we are going to try to blink the LED of the Arduino board itself every 1 second. So let's move to the next video. In this section of the course, we are going to be starting with our first project that will be blinking the inbuilt LED on the Arduino board for 1 second. So for that, first of all, we will connect our Arduino board with our computer. And once we are done with it, we will open our Arduino IDE, and we will open a new file by clicking on this new file, and we will get a code like this, or we will get this kind of new file in which there is a pre-written code which is void setup and void loop. These are two functions. We will discuss it about later. So after that, we will just click on tools, and we will select our Arduino board in our case we are using the Arduino Uno, so I will just select that and I will click again on tools and I will select the port as well. So in the port you can see our Arduino Uno is connected to the COM4. I will just select that and we are connected with our Arduino. So as soon as I will click on this upload button, it will upload the code to our Arduino and there will be no errors shown to us. So whenever you connect an Arduino board with your computer, you just need to go through this process of connecting it with the COM port and selecting the board name. So if you are using any other board, you can just select the name from this list. So once that is done, we are going to be starting with writing the code. So you can see here is a function called void setup. So void setup, inside here whatever we will write, it will run only once, and in the void loop the name itself suggests that it will repeat the task or it will run a loop inside the code that we will be writing inside this void loop function. So for now let's start writing the code. So inside the void setup we are going to be defining the LED, which is a built-in LED. So for that I will just type here pin mode, and the M will be capital as the Arduino IDE uses camel case. So we will just type pin mode with the capital M, and inside here we will just type LED underscore built-in, and we are going to be providing another parameter that will be as output, because this LED will be our output. And if you want to take an input from a sensor, you just need to type input in the pin mode. So once that is done, we will just add a semicolon at the end of this line and we will move forward in the void loop and we will try to write the code for blinking the LED. So in here we will just type digital. As we are sending the digital signal, we will just type digital write, and the W will be capital for the write. And inside here we will be just typing LED underscore built-in, and we will add a comma and type here hi. So it will turn on the LED for us, and we will add a semicolon in here and it will be providing a data as 1. So I will just try to add a comment in here and I will just type it will send data as 1 to turn on the LED. And in the next line we will just add a delay. So we want to blink the light, so we will just turn this LED light on for 1 second. So I will just add here 100 milliseconds. This time is in milliseconds, so 1000 milliseconds will be equals to 1 second. So in the next line we will again type digital write, and in here we are going to be providing LED underscore built-in, and now we will set it to low and the low will be capital, and in here we are going to be adding a semicolon at the end of this line and we will add the comment as well. So it will be sending data as 0 to turn off the LED, and at the end of it we will just add another delay of 1 second. I will just type in here and I will provide 1000 in here and I will add a semicolon. And once we are done with it, we will just try to save this code by typing Ctrl+S and we will just name it as, I will just try to select our folder in here. So here is a folder that I have created and I will just type here blink underscore built-in. And once we have saved the code, we will just try to compile it and verify it. So we will just click on this verify button and it will try to compile our code and see if there is any errors or not. So you can see here the compilation is done compiling. Now once we are done with that, we will just click on this upload button and upload this code on our Arduino to see the output of it. So let's just wait. And you can see on the Arduino the orange light is blinking, turning on and off every 1 second. So this is how you can blink the built-in LED on the Arduino board. So this was a startup project and we tried to understand how this code works. So if you have any doubts regarding it, you can leave them in the Q&A section and I will try to help you out with that. So that was it for this session. Let's move to the next video of the course. So in the previous video of the course, we have seen how we can blink the built-in LED on the Arduino board with the help of this code which we have created in our previous video. So in this video, what we will do is we will try to blink the LED, which is an external LED, using our code. So for that, first of all, we will try to connect the LED light with our Arduino board. So first of all, what we will do is we will connect the LED with the pin 13 of our Arduino board and see the output of it. So I will connect the positive end with the 13 and the negative end with the ground, and as you guys can see, the LED has started blinking. So this is because the built-in LED is directly connected to our pin number 13 and it gives the output to that pin number 13. So that's why our red LED is blinking. So now what we will do is we will remove the LED from pin 13 and we will insert the positive end to the pin 12 of the Arduino board. And once we are done, we will move towards our code. So we will click on files and we will create a new file. And in here, what we will do is, first of all, in the void setup, before the void setup, we will first of all initialize the pin number that we are going to be using. So here we will define int LED equals to 12. So basically we are defining the pin number that we are going to be using. So it is in form of integer value, and the pin 12 is defined here. It is defined in the form of integer value, and it is the pin 12 that we are going to be using to blink the LED and send the digital signal using the pin 12. So we will go in the void setup part and we will type here pin mode, and the M will be capital, and in here we will just provide LED and we will add a comma and type output, and the output will be in capital. Just do all caps here, and we will just close the bracket and add a semicolon at the end of it. And now in the previous video we have already written the code for the void loop. So in here what we will do is we will just try to replicate that code. So I will just minimize it and we will try to copy it from here, this part of code, and we will just paste it in there. And in here we will just change the values of the LED to the small LED. Here we have written LED underscore built-in. We will just replace it with LED, small LED, that we have defined here, you can see. And we will do the same here. Now what we will do is we will just try to save the code and we will name it as LED underscore blink, and we will save it. And after saving it, we will just try to verify the code by clicking on the verify button, and it will try to compile our code, and you can see it has compiled our code successfully. We will just see what error we will get if we remove one of the semicolons from here. So I will just remove this semicolon and we will try to save the code and again verify it, and you can see that it is showing us an error here. So just keep in mind that you don't miss any semicolons at the end of that line. So we will just add that here back and we will try to verify it again, and you can see it has compiled it successfully. We will just try to click on the upload button and see the output on our Arduino board, and as you guys can see, the LED has started blinking and we have successfully blinked an external LED. So in the next video we will try to blink a series of LED lights one by one. So we will be using 3 LED lights and we will blink them one by one. So let's move to the next video of this course. So in the previous video we have seen how we can blink this LED light with the digital pin 12. So in this video we will take a look at how we can blink a series of LEDs, which will be 3 LEDs one by one every second. So what we will do is we will use a breadboard and a jumper wire to connect the LEDs with our Arduino board. So here is the breadboard that we are going to be using. So you can see it has different ports where we can connect the GPIO pins, and we will just remove this LED from the Arduino board. So what we will do is we will just connect this LEDs with our breadboard. So what I will do is I will just connect it in this format. I will just insert the negative end. The negative end is connected here, which will be providing the ground, and here is the digital pin that will be providing the digital signal. So we will connect the jumper wire in here, and one jumper wire will be connected to this series of ground connections that we will be needing. So I have connected one white LED. I will connect a green LED in the same format in here. I have attached it now. You can see 2 LEDs are connected, and I will connect a red LED as well in the same format. Now once we are done with that, we will connect an orange wire with this ground connection, and we will insert it in the ground connection of our Arduino board, and there will be 3 different color wires. I will attach here. I will connect it with the red wire with the red LED in this format. You can see it is connected next to the positive end of the LED, so it will send the digital signal. I will connect the green cable as well here. The green one will be connected to the positive end of the green LED, and I will connect the gray one to the white LED. And once we are done with the connection, we will just connect it with our Arduino board one by one. So we will connect the red LED to the pin 13, green LED to the pin 12, and the white LED to the pin 11. So let's do the connections. And the orange wire will go into the ground. First of all, I will connect the ground wire. The second one will be the red wire will go into the pin 13. The green will go in onto the pin 12 on the Arduino board. It started blinking as we have connected, and we have already uploaded the code for blinking the LED on the pin 12. Now we will connect the last LED on the pin 11. So here you can see how they are connected. So once we are done with it, we will move towards our code. So in the Arduino IDE, what we will do is we will create a new file in here, and we will just try to copy this entire code in there, in that new file that we have created. And we will just paste this code in here, and we will try to edit that code. So first of all, what we will do is we will just add the name of the LEDs in here. So I will type int LED underscore red equals to 13, The pin 12 one is the green LED, and we will define the white LED as well. That will be equals to pin 11, and we will just set the pin mode for all these pins. So I will just copy this code thrice here, and we will just add the name of the LEDs here. So I will just add it underscore red, underscore green, and at the end we'll add the white one here. And after that we just need to start writing the code here. So previously we have tried to blink the one LED at a time. So now what we want to do is we want to blink the turn on the first LED and turn off that LED. Then the second LED should turn on, and the third LED should turn on once the second LED is off. So for that I will just replicate this code 2 times more, and here we will just change the name of that LEDs. So I will just add here red, underscore red, and then first of all it will turn on the red LED and it will turn off the red LED. Once that is done, it will turn on the green LED. So we'll just add here green. We'll do the same here. We want to turn off that LED, and we want to turn on the white LED then after every 1 second, and this loop should go on infinitely. So I think this code should work, so we will just try to save this code. So we will just save this code with a name as multiple underscore LED underscore blink, and we will save this code, and we will verify the code by clicking on the verify button, and it should compile the code, and you can see there are no errors. So it means we have not missed any kind of syntax error. So let's just try to upload the code and see the output on our Arduino. So as you guys can see, our LEDs have started blinking, and you can see it on the output screen that our program is working perfectly fine, and it is blinking each LED one by one after every second. So this is how you can blink multiple LEDs in a series one by one for 1 second each. So if you have any doubts or issues regarding it, you can leave them in the Q&A session of the course, and I will be happy to help you out with that. So that was it for this session. Let's move to the next section of this course. So in the previous video of the course, we have seen how we can blink multiple LEDs in a series one by one for 1 second each, and it creates a pattern in that. So in this video, we will see how we can control the LED from the user input. So we will be giving the input to the Arduino, and we will accordingly control the LED. So if we want to turn on the LED, we will just type turn on or turn off by giving it the input through the serial monitor, which is available here. You can just see here is the serial monitor through which we can give the input to the Arduino board. So for writing that code, first of all we will open our previous code, which was for LED blink. So I will just go here and open this code where we have written the code to blink the LED on the pin 12. So after opening this file, I will just copy this code, and we will create a new file, and we will paste that code in here. Once we are done with it, we will just connect the red LED light on our Arduino board with the pin 12. The positive end will go to the pin 12 and the negative end will be connected to the ground. And once we are done with it, we will start modifying this code. So first of all, we will be creating a character using which we are going to be taking the input from the user. So for that, first of all, what we will do is we will come here where we have defined the LED pin 12. So after that, in the new line, we will just type here char input. So basically using it, we are going to be taking the input from the user. So we have named the variable as input, and the data type of it is character. So we will be taking the input in the form of characters. So after that, we will move towards the void setup, and in here, before this pin mode, we will add a new line, and here we will type serial.begin. So basically we are establishing a serial connection with our Arduino, and I'll just type begin, and in here we need to provide a baud rate at which we are going to be communicating with our Arduino board. So I will type here 9600, and we will close the bracket and add a semicolon at the end of it. So using this piece of line, we will be communicating with our Arduino in the serial mode, and we will be providing the data through this serial communication, and the baud rate for it we have selected 9600. So I will be providing a PDF in which you will be getting more knowledge and more details about this piece of code. So you can download it from the resources section of this video. So let's move towards the void loop and try to get the input from the user. So in here, what we will do is, before this digital write, we will type input equals to serial.read. So using this function, we are going to be reading the data from the serial monitor, and we will write it in this format, and I will add a semicolon at the end of it. Once we are done with it, we will create an if statement using which we will be determining if what is the input given in the serial monitor. So for that, in the next line, I will type here if in the input is equals to, we need to type it twice, so it will check for this input. So I will set it as Y. So if we give a input as Y, so it should turn on the LED. So I will add a curly braces here after this if, you can see here, and we will close it after this line. So I will just close it in here, and we will just remove this delays because we are not trying to blink the LED now. We will control the LED through the user commands, and we will add another if statement, and we will check for turning off the LED. So we'll type input equals to, and we'll try to add n for turning off the LED, and we will add curly braces in here, and we will just remove this delay from here, and we will close that curly braces. And I think we can also add a serial print here. So after this pin mode, we will just ask our user to provide the input. So I will just type here serial dot print, and in here we will provide a text where we will ask our user to press Y to turn on the LED and press N to turn off the LED. So I will just write it in here. Press Y to turn on the LED, and I will try to add a /n in the next line. It should ask our user to press N to turn off the LED. And once we are done with it, we will try to just save the code, and we will set it as input underscore LED underscore control, and we will save the code and we will try to first verify it. So I will just click on this verify button and it should compile our code, and if there is any error, so we will be able to see that. So I think we have not missed any kind of semicolon, or we are not having any kind of syntax error. So our code has compiled successfully. Now what we will do is we will try to upload it by clicking on the upload button, and we will see the output on our Arduino. So let's just try to upload the code. So now our code is successfully uploaded onto our Arduino board, and you can see on the output screen that the LED is turned off. So now what we will do is we will click on the serial monitor, and you can see it is asking to press Y to turn on the LED and press N to turn off the LED, as we have written in this serial print. So now we will try to turn on the LED by typing capital Y. So just keep in mind that it is case sensitive, so we need to keep in mind that if we have typed capital Y in the input, so we need type capital Y in the serial monitor as well, otherwise it will not work. So let's just try with the small y first. So let's see if it is turning on the LED. So you can see it is not working. So let me try with the capital Y, and you can see on the Arduino that the LED has turned on. Now let's just try turning off the LED by typing N, and we will hit enter, and you can see on the Arduino the LED has turned off. So using which we can control the LED easily through the user input with the help of the serial monitor and the code which we have written with the help of serial input and serial read. So this is how you can take the input from the user and control the LED or any other sensor with the help of this piece of code. So if you have any doubts regarding it, you can leave them in the Q&A session of the course, and I will try to help you out with that. So that was it for this video. Let's move to the next video of the course. In the previous video of the course, we have seen how we can control the LED using the user input with the help of the serial input. So in this video, we will take a look at how we can control a relay module using the same code which we have written in the previous video. So you can see on the screen, I have this relay module, which is a 4-channel relay module, using which we are going to be controlling this relay with the help of the code that we have written for controlling the LED through the user input. So now you can see there are basically 6 pins which are available on this relay module. The first one is the ground pin, and the other 4 are the digital pin for controlling the relay modules, and the last one is the 5V. So basically we need to connect the ground with the ground wire and the VCC with the 5V on the Arduino board. So let me first connect it. So we will connect it using this kind of jumper wires, which will be female to male. So basically these are the male connectors on this relay module. So we need to connect it with this female connector here. So I will just connect these two, the last one and the first one, using these 2 jumper wires. So now I have connected these 2 wires here, and here are the other 2 ends of it. So we will be connecting these 2 ends to, one will go to the ground and second one will go to the 5V on the Arduino board. And we will also connecting another GPIO pin with the pin 12 on the Arduino board. So let me get another wire. I will be connecting it on the in one on the relay module. You can see here I've connected it successfully, and we will connect these wires onto our Arduino board. So the gray one will go into the ground on the Arduino board, and the purple one will go into the 5V. And after that, we will connect this black wire with the pin 12 on the Arduino board. So I will just remove this LED from here and insert this in here. And you can see the red light has turned on here. so it means the relay module has started. So now what we will do is we will move towards our computer screen and see if it is able to turn on the relay module or not. So now what we will do is we will just try to give the command using this serial monitor. So I will first of all type N to turn off the relay module, and you can see it is not working because now the inputs are inverted. So if we will provide low at that time, it will turn on the relay, and when we will be providing high, it will be turning off the relay. So let's try by typing Y and see if the relay module turns off. And you can see on the screen it has turned off the relay module. Let's try with the N, and you can see now the relay module has turned on. So what we will do is we will just replace these two inputs. So for that we will just go in this input, and we will just type N here, and we will type Y where we have low, and we will type N in the high where we are doing the digital write high. We have replaced the input as N, and we have replaced the low with the Y. So now we will verify the code and we will just upload it. So now it will solve the issue for us. So let's just see the output on the output screen. So let's try typing N first. So you can see on the screen the relay module has turned off, and let's type Y. So it has turned on the relay module. So this is how you can control the relay module using the user input with the help of the serial monitor. So in the next video, we will try to connect an bulb with this relay module and try to control that bulb with the help of this user input code. So let's move to the next video of the course. In this video of the course, we will try to control all the relays on the relay module, which are in total 4, at the same time using our code. So for example, if you want to turn on all the 4 appliances that are connected with our relay module at the same time, so we will be writing the code for that. So you will be able to control all the 4 relays at the same time by turning them on as well as off, and you will be also able to control them individually. So if you want to just turn on a specific relay, you will be able to do that. So for that, I will just need to connect the other 3 relays with our Arduino board on the pin 11, 10 and 9. Here are some jumper wires with me, and I will just try to connect them with our Arduino board. So I will just connect the second, third and fourth relay on the pin 11, 10 and 9 on our Arduino board. So let me just connect them. So I have connected the jumper wires with the relay module, and I will insert this other 3 ends onto our Arduino board. So finally we have connected all the 4 relays from our relay module with our Arduino board. So now we will move to our computer screen and try to write down the code for controlling all the 4 relays at the same time. So let's move to our computer screen now. So now on the computer screen, you can see that I have opened the previous code that we used to control a single relay module with the help of our Arduino board through the serial input. So now what we will do is we will just make some changes into it. First of all, I will just replace the LED with relay 1, which is connected to our pin 12 on our Arduino board. And similarly, I will just copy it and we will paste it here, and we will just replace this relay 1 to relay 2, and it is connected with pin 11. So we'll just set it to 11, and the relay 3 connected to pin 10 on our Arduino board, and the fourth relay is connected on the pin number 9. So I will just add here 9, and after that we will just move into our white setup, and we will just try to replace this thing with the relay 1, and we will just make 3 more copies of it and change the number of relay from here. So I will just do it to 2, 3 and 4. And after that, you can see in the void loop, we have created some conditions, which are some if conditions. So if we press Y, it will turn on the relay 1, and if we press N, it will turn off the relay 1. So similarly, we will just create some more conditions for controlling the other relays. So first of all, I just need to replace this LED with relay 1 and replace the LED with relay 1. So I will just add it in here, and after that we will just copy this entire piece of code which is controlling the relay 1, and similarly we are going to be using this code to control the relay 2, and we will just change the characters in here. So I will just set it to capital O and capital F for on and off, and in the next line we'll just paste it again, and we will just change the number of relay here from 1 to 2. Capital O and F will be used to control the relay 2, and let's just try to add 0 and 1 for the relay 3. So if we press 1, it will turn on the relay, and if we press 0, so it should turn off the relay. And I will just replace the relay to relay 3, and we will just try to paste the same thing again here, and this time let's just give the input as small o and small f. So this Arduino code is case sensitive, so we just need to keep in mind that whatever case we are using in this input, we just need to provide that, otherwise it will not work. So right now you can see I have a capital O and a small o, so these two are different for our Arduino code, and it will be turning on if we provide capital O, the relay 2, and if we provide small o, it will turn on the relay 4 for us. So now after that, what we will do is we will add another if statement to control all the 4 relays at the same time. So I will just type here if, and inside this input we will be checking it for A. So we will use capital A to turn on all the 4 relays at the same time, and I'll just create the brackets here. And what we will do is we will just write down the code for turning on all the 4 relays at the same time by typing digital write and the number of that relay. So let me just do that, and you can see I have added all the relays one by one here. So first one is the digital write relay 1, and we are turning on the relay, and similarly we are doing it for all the other relays. And after that, what we will do is we will try to just add another if statement, and we will just check for an input, which will be input equals to small letter A. So if it is in the form of small letter, we want to turn off all the relays. And as you guys can see, I have set the digital write relay 1 to high, and it will turn off the relay for us, and I have done it for all the other relays as well. And after adding this line of code, we will just scroll up and we will just see this serial.print, and we will just try to change it for our appropriate inputs. So we will just do press Y for So now after that, we will just try to save our code, and I will just name it as relay underscore 4 underscore control. And after that, I will just save it. And after that, we will just click on verify, and it should compile our code. And after that, we will just try to upload it on our Arduino board. And it has successfully uploaded the code onto our Arduino board, and I can see that all the 4 relays has automatically turned on. So now what we will do is we will just scroll down, and we will just copy this code to turn off all the 4 relays. So as soon as we upload the code, the relays will automatically turn off with the help of this piece of code. So I will just try to remove the spaces from here, and I will just save it and upload it again. And Now all the relays are off, as you guys can see on the screen. So now what I will do is I will just open the serial monitor, and you can see here are the inputs that we have written here in the print line. So now we will just try to control the first relay with the help of capital Y. We will just try to turn on the first relay, and let's see the output of it. And you can see the first relay has turned on. Let's just try turning on the third relay by typing 1. And you can see the third relay has turned on. Let's just try turning on the fourth relay by typing small o. And you can see the fourth relay has turned on. And finally, we will just try to turn on the second relay by typing capital O. And you can see on the screen all the relays are perfectly working. And let's just try controlling all the 4 relays at the same time. So now all the 4 relays are turned on. So I will just type A, which will be a small a, to turn off all the relays. So let's just try it once. So you can see all the relays has turned off. Let's just try turning them on. And you can see all the 4 relays are working perfectly fine with the help of our code. So you can now control all the 4 devices with it, which are connected to your relay module with the help of this code through the serial monitor. So that was it for this video. Let's move to the next video of the course. So in the previous video of the course, we have seen how we can control the relay module using the user input through the serial monitor. So in this video, we will be connecting a bulb holder with our relay module and try to control this bulb using it. So this is a 9-volt bulb that we are going to be connecting with our relay module and trying to control the bulb using our relay module. So for that, first of all, we will be needing some components. So basically, we are going to be needing these 2 things. The first one is the bulb holder, in which we can attach this bulb that we have, and we can connect it in this format. And after connecting it, we can control this bulb with the help of the relay module. So this is how the bulb will be connected with the bulb holder. And we also need a plug to power up this bulb from the main source. So just keep in mind that we are going to be working on a test bench. So basically, using these 2 components, we are going to be creating a test bench on which we are going to be performing different home automation operations, and we are going to be testing the things, implementing in our entire house. So just be extra cautious when you connect it with the power supply, and when the power is going through the wires, so it might give you a shock. So just use proper precautions while working with this 2 things. And we have connected some wires with it. So basically, I will be providing you the schematic diagram in the resources section, so you can go there and create this kind of loop that we have made here. So you can see one end from this bulb is directly connected to the power plug that we have here. One end of this power plug is connected with this bulb, and the other 2 ends from these 2 components are free. So we will be connecting these 2 wires to control the bulb using our relay module. So you can see on the screen, here is the schematic diagram of it, and here is how you need to connect it. So once we are done with it, we'll just connect these 2 wires onto our relay module on the relay number 1. So let me connect it first. So once we are done with the connection, now what we will do is we will just plug the bulb in the bulb holder. And we will keep it in here, so you will be able to see if it is able to turn on the bulb or not. So I will just set the things here, and we have left with this power plug. So we will be powering it with the help of our mains board. So I will just try to plug it in, and I will turn off the switch of the mains board where I am connecting it. So once we are done with it, we will be moving towards our computer screen, and for now we will be not turning on the power for this LED bulb connection, and we will first try to like control the relay module first, and after that we will be turning on the power for this bulb. So let's move to our computer screen. So now we are back on our computer screen. So what we will do is now we will click on this serial monitor and try to see the output. So as you can see on the screen that the bulb is off. Let's try to turn on the bulb by typing Y, and we will just turn on the switch for the power of the bulb. So I have just turned it on, and we will try to send the command Y to turn on the bulb. So let's see if it is working or not. So I will hit enter, and you can see on the screen that the bulb has turned on now. And let's try turning off the bulb by passing the command N to turn off the bulb, and you can see the bulb has turned off. So we can similarly try to turn it on and turn off. And using this code and this schematic diagram with the help of this bulb holder and the power plug and this bulb, we can control the LED light in our home with the help of the Arduino, and with just a command we can turn it on and turn it off. So using it, we have made a smart bulb system with the help of our Arduino and relay module. So that was it for this video. In the next video, we will try to see and create another exciting project in which we are going to be connecting this bulb to a two-way switch. So basically it will be able to control through our Arduino board as well as the switch. So for now we are only able to control it through the serial monitor by giving it the command Y and N. So in that case we will be also able to control it through a switch, and both the things will be working simultaneously. So I hope you are excited for the next project. So let's move to the next video of the course. So in the previous video of the course, we have seen how we can control this bulb using our relay module and the user input through the Arduino board. So basically we have created the smart bulb that can be controlled from our Arduino board with the help of the user input. So user can type Y to turn on this bulb and type N to turn off this bulb. So in this video what we will do is we will connect a two-way switch with this bulb and relay module to control it through the switch as well as through the Arduino commands. So you can see on the screen that we have this kind of two-way switch that we are going to be connecting with our relay module, and we are going to be trying to control this bulb with the help of this switch as well as the Arduino code. So you can see it has basically three inputs. So these two inputs will go into the relay module input, where we have basically, you can see on the screen that it has three inputs. So we will just remove this last one and we will connect it in the middle of this two-way switch, and these two wires will go in these two connections, the first one and the last one, and the middle will be connected from this bulb. So I will just try to remove the last wire from here. So just check if you have removed the mains cable, and also turn off the switch and see if all the cables are removed, so you won't get any kind of shock. And please be extra cautious when you touch the relay module. If you have power on your main switch, it will be getting current through this relay module. So just be extra cautious about turning off the switch every time you try to connect anything to the relay module. So I've checked it twice. Now we will just remove this last cable. And you can see I have removed this cable from here, and the only cable which is connected is the middle cable which is coming from our bulb, and I have removed the cable which is coming from our switch, which is our main socket through which we are connecting the power. So we will be inserting it inside this two-way switch in the middle input of it. And once we are done with it, you can see here is the output of how we connect the cable. And now these two cables will go directly into the relay module. So this end will go to the first, and this one will go to the last. Basically, the relay module has 3 inputs: positive, negative, and neutral. So these two will go to positive and negative, and the middle one is the neutral. So let's try to connect it. So finally we have connected the relay module and the two-way switch, and you can see here is the output of it. And once we are done with it, we will move to our computer screen and try to give the command. And before that, just keep in mind that you turn off the switch first, and then only you proceed with the further execution of the code. And so now after coming to the computer screen, what we will do is we will just click on this serial monitor, and after that we will just type Y and see if the relay module is working with the bulb or not, if it is turning it on or not. So let's just try it. So you can see now the bulb is turned on, and let's just try by turning it off. So you can see it is working. So let's just try to turn on the bulb, and at the same time we will turn off the switch and see if it is working with the two-way switch or not. And as you guys can see, the bulb has turned off after we turned off the switch from the two-way switch, and still the relay module is on. You can see the red light is still on. So let's just try to type Y from here and see if it turns on the bulb or not. And you can see we get no result and the bulb is still off. So what we will do is we will try to type N this time, and you can see the bulb has turned on again. So basically when we use the two-way switch, it inverts the input for the relay module. So if the switch is turned off, at that time it will ask for the input as Y to turn on the bulb and N to turn off the bulb. And when it is on, so we need to type N to turn on the bulb and type Y to turn off the bulb. So let's just try typing Y to turn off the bulb, and you can see it is working perfectly fine. And let's just try to turn off the two-way switch and see the output of it. And as you guys can see on your screen, the bulb has turned on through the switch. Now we will just try to turn it off by typing N, and you can see it is back to the original position. So this is how you can control the bulb using the user input, as well as at the same time you can control it with the two-way switch. So that was it for this video. Let's move to the next video of this course. So far in the course, we have tried to blink the built-in LED on the Arduino board. After that, we tried to blink an external LED, which was a red LED from the pin 12. And after that, we tried to blink a series of LED one by one after 1 second each, and it was creating a unique pattern in that. But now in the course, we will try to blink a bulb using our code. So for that, what we will do is, first of all, we will just close this serial monitor from here, and we will go into the files where we have the blink code for the LED which was connected on our pin 12. So we will just try to open that code, and still our relay module is connected to the pin 12 on our Arduino board. So now we will just rename this LED to relay 1, and after that we will be replacing the LED from the entire code with the relay 1. So we will just try to select this and paste relay 1 here. Similarly, we will do it for this part where we are doing it digital high, and same for the low. And we will try to save this code, and what we will do is we will try to verify the code to see if it is compiling successfully or not. And you can see on the screen it has done compiling. So let's just try to upload this code and see the output of it. So as you guys can see on the output screen, the bulb is blinking and turning on for 1 second and turning off for 1 second, and it sounds like a ticking of the clock, and the relay module is making that sound. So you can see on the output screen the bulb is turning on and off, and it seems like really stupid, but it is for experimenting purpose, and like you will be able to see how a bulb blinks and you're controlling this bulb with the help of an Arduino code. So isn't it exciting? So I hope you're loving this course so far. So that was it for this video. Let's move to the next video of the course. So previously in the course, we have tried to create a smart bulb with the help of the relay module, and we tried to control the bulb using the user command from the serial monitor, as well as we tried to control it with the two-way switch and the user command. So in this section of the course, we will try to create a smart socket with the help of the relay module. So you can see this is the socket which I am going to be using, and whatever we will plug into this smart socket, it will become a smart plug with the help of it. So I will be leaving the schematic diagram for it in the resources section of this video, and it is exactly same as the connection for the smart bulb. So we are using the same adapter, the power pin, and we have just replaced the bulb holder with this socket, and we have connected the ends here, and we will be having two outputs of it, and we will be connecting it into the negative and the neutral of the relay module. So let's just try connecting it with the relay module. So once we have connected this smart plug with our relay module, we will move to our computer screen. And so after we move to our computer screen, what we will do is we will open the sketch, which is the input underscore LED underscore control, and we will try to upload it onto our Arduino board. So I will just try to verify it, and it is the same code that we were using previously to control the bulb, and I will try to upload it onto our Arduino board. And now the code is successfully uploaded onto the Arduino board, and the relay module has turned on, and I will just try to turn it off for now, and I will try to show you the output of it by connecting an lamp with this smart socket which we have created. So let me just attach the lamp with the smart socket, and I will be back. So as you guys can see on the output screen that I have connected the lamp with our smart socket. So now what we will do is we will just try to give it the command and try to turn the lamp on with the help of Y, and you can see the lamp has turned on. Let's try turning it off by typing N, and you can see it has turned off. So we can try it multiple times, and you can see the output on your screen. Just imagine what you can connect with this smart socket. Everything you can connect with this socket will be turning into smart, and you can be able to control it through your Arduino board with the user input. So you can connect a mobile charger, laptop charger, your laptop, your computer, your TV, your washing machine, your AC, your coffee machine, and the list goes on, and you can connect them using the smart socket that we have created, and you can control it through the Arduino board with the help of the user input, and you can just turn them on and off through your serial monitor. And I'm damn sure you're going to be connecting a lot of appliances with this smart socket and try to control them with the help of the serial monitor and the user input. So that was it for this video. Let's move to the next video of the course. In this video, we will be making a timer based socket using which we can control it at a particular time. So there was an issue last year during the pandemic. I was at my home, and during that time I used to use my laptop which has an inbuilt battery. So I used to plug it in for 24/7, and the battery got damaged and it got overcharged, due to which I have to replace the battery, and it was quite expensive. So to overcome that problem of overcharging the batteries of my laptop and other devices, what I did was I created this timer based socket using which I can connect my devices with it, and it will automatically turn off after the timer that we have set is over. So for example, if you want to charge your mobile phone and it takes around 2 hours to charge it, you can just set the timers for 2 hours and it will automatically turn off the socket as soon as 2 hours are over. So you don't need to worry about your devices getting overcharged or overheated due to the excess amount of electricity that we are providing to that device, and your devices will be not getting damaged due to that thing. So for that, let's do the connection first, and then we will move to our computer screen to write the code. So you can see this is the socket which I am going to be using, and whatever we will plug into this smart socket, it will become a smart plug with the help of it. So I will be leaving the schematic diagram for it in the resources section of this video, and it is exactly same as the connection for the smart bulb. So we are using the same adapter, the power pin, and we have just replaced the bulb holder with this socket, and we have connected the ends here, and we will be having two outputs of it, and we will be connecting it into the negative and the neutral of the relay module. So let's just try connecting it with the relay module. So once we have connected this smart plug with our relay module, we will move to our computer screen. So in the Arduino IDE, I have opened our previous sketch that we used to control the smart socket with the help of the user input. So now in the same code, we are going to be making some changes to control it with the timer. So first of all, we will be just taking a look at what is the formula to convert the milliseconds into minutes. So for example, we want to turn on the socket for 1 hour. So in that case, we want it to turn on for 60 minutes. And for that, first of all, we need to take the number of minutes, which will be equals to 60. And we have to multiply it with the 1000, because the delay that we are going to be giving is in the form of milliseconds in the delay input. So we are going to be using the delay function, and in that we are going to be providing this entire calculation that we are doing here. So in here, if we want to turn on the relay module or our socket for 1 second, we need to type 1000 and we need to add a semicolon. At that time, it will turn on the socket for 1 second, and similarly we want it to turn on the socket for around 1 hour. So we also need to add another multiplication here with 60. So using this calculation, we will be able to get the exact time and the exact delay that we need to turn on the relay module for around 1 hour. So it will be equals to, and I will be just adding the calculations here, and the answer will be 365 times 0. So I will just add it in here, and we need to provide this exact number in the delay. So it will be turning on the relay module for 1 hour exactly, and it will be turning it off after that amount of time is finished. So if you want to similarly add a timer for 2 hours, so you can just change it to 120 minutes, and it will be exactly same multiplied by 1060. Here we are multiplying it for the milliseconds. We are converting the milliseconds into seconds, and then we are converting the seconds into minutes in this line of code. So in the serial print, I will be just editing this line of code, and we will be just doing it for two inputs. The first one will be for 30 minutes and the second one will be 60 minutes, and we have just calculated the output in here. So if you want to just calculate it, you can just open the calculator and you just need to type the values in here. So we want to do it for 60 minutes into 1000, and you get 60,000, and we are going to be multiplying it by 60, and here is the final answer. And you can see we have written the exact same thing here, and we will be also calculating the same for 30 minutes. So I will just erase it. I will do 30 into 1000. It will be 30,000 and into 60, and you can see here is the output for that. And I will just copy this number and I will be just pasting it in here in this comment, and later on we will be adding this exact same numbers into our code, so I don't forget the exact number. And we just need to remove these commas from here because the IDE won't support that. And after that I will just edit this line of code and ask the user to press Y for 1 hour timer, and we will add a /n, and after that we will just type the exact same thing here and just replace the Y with n and 1 hour with 30 minutes into 30 minutes. And after that we don't need to change anything in here, and after that we just need to go inside this if statement where we have the digital write, and after that we just need to add a delay that we have here pasted. So we want to set a delay for 1 hour here, so I will just type here 1 hour delay, and in the next line we just need to turn off the relay module. So you can see in the end we are just turning off the socket, so I will just copy this line of code to turn on the socket for us, and I will just paste it in here. And after this line of code is executed, after that we want to turn off the socket, so I will just add it in here, and I will just replace the low with high, so it will turn off the module for us. And after that I will just copy these 3 lines of code and paste it in the other if statement that we have. So I will just paste it in here, and we will just copy this delay from here for the 30 minutes, and we will just replace it from this delay which we have here for 1 hour, and then we will just replace this thing to 30 minutes. And after that we also need to just replace this inputs from here because we have set 1 hour for Y and 30 minutes for N. And after that we can just upload this code onto our Arduino board, and you don't need to give any kind of input or worry about your devices getting overcharged. You just need to type Y for turning on the smart socket for 1 hour and press N for turning it on for 30 minutes, and it will automatically turn off after the time is done, and you don't need to worry about your devices getting overcharged or getting their batteries replaced, and it will save you a lot of money. So you can try uploading the code onto your Arduino board and see the output in action. So that was it for this video. Let's move to the next video of the course. So in this section of the course, we will try to create a smart lamp with different features. So in this video, we will take a look at how we can control a lamp on the intensity of the light in the room. So for example, if it is too dark in the room, the lamp should automatically turn on, and if the light is already on, the lamp should automatically turn off. So it will be acting like a emergency light for our room. So if it is too dark, so we will be still able to see something in the room, so we don't fall on something or we break something because of the darkness in the room. Keeping that in mind, we are going to be creating this project. So for that, first of all, we will get our breadboard. So for that, we will need 2 components. The first one will be an LDR sensor, which stands for light dependent resistor according to the intensity of light. So it will be getting the intensity of light, and according to that we will try to control the lamp. And here is a resistor that we will be needing to connect with this LDR sensor. So let's just create the circuit on the breadboard first. So I will just try to insert the resistor on the breadboard, and I will connect it in this format. You can see here I have connected it in this format, and we will just connect our LDR sensor with it. So it will be connected with the same input as the resistor, so they both will be connecting with each other. And using this middle interaction of these two pins, we will get the analog output, and this part of the LDR sensor will go into the 5 volts. 5 volt will be connected here, this end, and the resistor will be connected to the ground pin. So let's just do the connections through our Arduino board. So for that I will just extend the ground and the 5 volt onto our breadboard first. So I will be connecting these two jumper wires on the LDR pin first. So I will connect the gray one on the LDR, and the white one will go into the ground pin, and we will connect it with our resistor. And once we are done with it, we will just remove the pins from our Arduino board for our relay module, and we will connect the 5 volt of the relay module with LDR sensors extension, where we have extended the 5 volt, and the ground will go into the extension of the resistor where we have extended this ground pin. I will just connect it here, and after that we will just connect these two pins on the ground and the 5 volt of the Arduino board. So once we have connected the ground and the 5 volt with our Arduino board, what we will do is we will just connect this black jumper wire with our A0 on the Arduino board, which is here. You can see this is the A0 port using which we can get the analog input. So we will just connect it there, and the other end of this black jumper wire will go into the intersection of the resistor and the LDR, where we have connected it in a common input. So we'll just connect it there, and our sensor will be able to send the analog signal to our Arduino board. And the relay module is still connected with our Arduino on the pin 12, and you can see here is the smart socket that we have created. So we are going to be using this socket to connect the lamp with our relay module and try to control it. So I will just keep it aside, and the other connection will be same as the previous videos. And once we are done with it, we will move to our computer screen and try to write the code for it. So let's move to our computer screen now. So once we move to our computer screen, what we will do is we will open a new file, and we will try to create a new project in which we will be defining some new pins. So as we connected the A0 with the input of the LDR, so for that, first of all, we will define that pin here. I will type here int LDR, which will be equals to A0. So we'll just type here A, capital A, and we will type 0. So this will be getting the analog input for LDR. So I will just add a comment here, input from LDR. So after that, we will be defining an int value, which will be the value of the intensity of light. So I will set it to 0. So we are going to be checking this value, and we will try to add an if statement, and if the value is less than a particular amount of intensity, we will try to turn on the lamp or turn off the lamp accordingly. And once we are done with it, we will just type here int relay 1, which will be equals to pin 12. So basically we have connected with our relay on the pin 12, which is a digital pin. So I will just add a comment here, I will type relay output pin. So we will be basically getting the output through this relay 1 for the input of the LDR. So after that we will move into our void setup, and in that, first of all, we will just initialize the serial begin. So I will just type here serial begin, and inside it we will just pass the baud rate as 9600. We will close the brackets and add a semicolon at the end of it, and in the new line I will just type here pin mode, and we will just add relay 1 as our output. So I will just type it in all caps, output, and we have set our relay 1 as the output, and we don't need to add the input in here in the pin mode. What we will do is instead we will go inside this void loop, and in the void loop we will just add value which will be equals to analog read, and as you can see, analog read is following the camel case here. So just see the camel case and try to write it accordingly, and we will just pass the LDR pin in here, and we will try to get the analog input or the analog sensor data through analog read, and we will just pass the LDR in here. And once we are done with it, we will just try to print the values on our serial monitor. So I will just type serial dot print ln, so it will print the output on a new line, and in here we will just write LDR value is, and we will add colon here. We will also add some spaces, and we will just close this bracket here, and I will just try to add a comment here so you better understand what this line of code is doing. So it will read the value of LDR. Basically the LDR is going to get the intensity of the light, and we will be getting it in the form of an analog input. So once we are done with it, we will just add the serial dot println, and we will be printing out the value, the actual value of the LDR sensors. So I will just add it in here, and after that we will try to just see the output of it by uploading the code onto our Arduino, and we will see what is the intensity that we will get. So let me just try to first save the code as LDR underscore lamp, set it to this, and I think I have done some spelling mistake here. Okay, would be relay. Okay, let's try compiling the code again, and you can see the compilation has successfully done. So let's try uploading the code to the Arduino. So we will just click on upload, and it will upload the sketch on the Arduino, and you can see the uploading has successfully done. So let's open the serial monitor and see what output we get. And you guys can see here is the output that we are getting. So you can see we are getting an output as 153, 154, and it is changing continuously. And what I will do is I will just try to put my hand above the LDR sensor, and let's see if the values changes or not. And as you guys can see, the values are changing, and it is going below 100 as well. So what we will do is we will set the threshold value to 100, and you can see that the light intensity is changing as I'm moving my hand up and down. So, and what I will do is I will just turn off the light of my room and show you the output of it. And as you guys can see, the values have dropped below, and it is around 1 and 0. So you can see it is too dark in my room, and you might be able to see the lights of the Arduino still. So I will just turn on the lights back again, and you can see now the values are back to 240 and to 39. So we understood that the basic threshold is around 100. So what we will do is we will just turn on the lights if the threshold is below 100. So for that, first of all, we will just close this serial monitor, and after this serial print value, we will just add an if statement, and I will just type here if, and inside this if, we are going to be providing a condition. We will type value is less than 100. At that time we want to turn on the lights, so we will do digital right, and inside that we will provide the relay one, and I will add a comma, and we will set it to low, and we will add a semicolon at the end of it. So what it will do is it will turn on the relay, on the relay with the lamp, and after that we will just add an else statement, and inside this else statement we will just add digital right, and in here we will just set it to high, so it will turn off the relay module. So I will just paste it in here, and I will set it to high, and after that I will add the semicolon, and after that we will add an comment here, so it will turn off the relay with lamp. So let's just try saving the code and try to upload it on our Arduino board. So first of all, we will just compile it, and you can see there are no errors now, and we will just try to upload it onto our Arduino board. And as you guys can see on the output screen, the relay module is off now, and if I try to like put my hand above it, it will turn on the relay module. So as you guys can see now, if the light intensity is below 100, it will turn on the relay module, and if it is above 100, it will automatically turn off the relay module. So let's see the project in action now. So finally I have connected our lamp with our smart socket, and I have also placed the LDR sensor aside from the lamp, so it won't get the light from the lamp directly. If it gets the light from the lamp, it will continuously turn on and turn off the relay, and it will be creating a mess for us. So I have put it aside. You can see here is the LDR sensor, and I have connected everything properly. So now what I will do is I will just turn off the light of my room and show you the output of it. And on the screen you can see the lamp has turned on automatically, and if I try to just open the torch of my mobile phone, and if I will be showing it to our LDR sensor, it will turn off the lamp for us. So let me just do that, and you can see the lamp has turned off. And if I just remove this light source from here, you can see it has turned on the lamp. You can also see the output on the serial monitor. You can see here is the output that we are getting, and if I just try to show the lights toward it, you can see the intensity has increased to 300, and if I just remove it, you can see it has turned on the lamp, and the intensity is now below 100, and it is able to control the lamp for us. So using this lamp, you don't need to turn on the lamp again and again, and you don't need to play around with your lights. It will automatically turn on your lamp, which will be a table lamp without any user input as soon as it is dark in the room. So you won't hit anything, or you don't fall on anything. You will be able to see something in the room, and you will be able to grab the things from your table as well. So it will be acting as a secondary light source for you. So isn't it exciting that we have created our LDR based lamp, using which we can turn it on automatically if it is dark in the room, and if it gets some kind of light source, it will automatically turn off the lamp for us. So that was it for this video. Let's move to the next video of this course. In this video of the course, we will try to create a smart lamp that will be automatically turning on if it detects any kind of motion with the help of the PIR sensor or a motion sensor. You can see on the screen, this is the PIR sensor that we are going to be using to control the lamp with the help of the motion. So for that, first of all, we need to connect it with our Arduino board. So we will just connect this PIR sensor with our Arduino board. So you can see here are the 3 pins on the PIR sensor. The first one is the 5 volt, the second one is the digital in, and the third one is the ground. So we will just connect some jumper cables with it. Here are the jumper wires, and we will insert these jumper wires with our PIR sensor. And once we are connected, we'll just connect them on our Arduino board. So I will just connect the ground pin with the ground that we have extended onto our breadboard. I have connected that, and now we will just connect the 5 volt with the 5 volt on the Arduino board through the extension, and we will be connecting the digital in onto our Arduino board on the pin 8 of the Arduino board. So I will just connect it over there, and once we are done with it, we will just put our motion sensor towards the opposite side like this. You can see now it is placed in here, and all the components are connected as they were in the previous videos. So we just need to connect this PIR sensor with it, and once we are done with it, we will move to our computer screen and try to write down the code for it. So let's move to our computer screen. So now in the Arduino IDE, we will click on file and open a new file, and we will try to write down the code in here. So for that, first of all, we will be just declaring the sensor pin for the motion sensor. So I will just type here int PIR, which will be equals to 8. So basically we have connected the digital pin of the PIR sensor with the pin 8 on the Arduino. So it will get the input from the motion sensor slash PIR, and in the next line we will just create another variable with the name relay1 that will be equals to 12, where our relay module is connected. And after that, in the new line, we will just type int state. So we will set it to low, and we will be using it to check whether the motion sensor has detected any motion or not. And after that, in the next line, we will create another variable named val that will be equals to 0, and using it we will be just try to check if the motion sensor has detected any motion or not. So in the void setup, what we will do is we will just set the pin mode. So I will just type here pin mode, and I will set the pin mode for the relay 1. So I will just type here relay 1, and then we will add a comma, and we'll set it to output, and we will just close the bracket and add a semicolon at the end of it. And in the next line we will do pin mode, and here we will be defining the sensor. So I will just type here PIR, and it will be an input for our code, and I will add a semicolon at the end of it, and we will just type here serial dot begin, and the baud rate will be 9600, and we will just add a semicolon at the end of it. And once we are done with it, we will move towards our loop, and inside this loop, first of all, we will type val, which will be equals to digital read, and the digital read is in the form of camel case. Inside it we are going to be providing PIR, which is our motion sensor pin, and it will try to get the value for it. And we will just check for an if condition. So I will add if the value is equals to high, at that time what we want our code to do is we want our code to do digital right, and in here we will just pass our relay 1, and I will add a comma, and I will set it to low, and we will add a semicolon at the end of it, and we will just provide it a delay of 100 milliseconds by adding here 100, and I will add a semicolon at the end of it. And after that we will be just checking the state of it and trying to show the output on the serial monitor. So I will just type here if state, and the state is equals to low. At that time we will just try to show the user through the serial monitor that the motion is detected. So I will just type here serial dot print ln, and we're going to be printing that motion is detected. So I will just type here motion detected, and at the end of it we will just close the bracket and add a semicolon, and we will change the state to high. So basically in this case what we are doing is if the value is high, at that time we see that the motion is detected, and at that time what we are doing is we are just turning on the relay module by setting it to low, because the relay module works invertedly, like if we provide high, at that time the relay modules turns off, and when we provide low it turns on. Basically we have seen the same formula while doing the two-way switch. So after turning on the relay, what we are doing is we are checking for the state. If it is equals to low, first of all we have set it to low. At that time we are printing that motion has detected, and we are setting it to high. And after that we will be checking for an else condition outside this if statement that we have created here. So I will just click here. You can see this is the end bracket of this if, and after that we will just type else, and inside this else we'll do digital right, and in here we will be providing the relay 1, and we will set it to high, so it will turn off the relay module, and we will just add a semicolon at the end of it, and we will just provide a delay of 100 milliseconds here. So I will do 100, or you can do it 500 as well, so it will not constantly turn on and turn off the lamp for us. So I will just set it to 500 milliseconds, and after that we will be adding another if statement to check the state. So I will just add if the state is equals to high, and I will just remove one equals to from here. And in that case what we will do is we will just try to show it on the serial monitor. So I will just type serial print ln, and in here I will just type motion stopped, and I will just close this bracket, and we will set the state to low. So using this entire piece of code, we are just turning off the relay module with the lamp, and using it we are going to be turning it on. So let me just try to add a comment in here. It will turn on the lamp, so you can understand what each and every line of code is doing, and it will print on serial monitor that the motion is detected, and we are just updating the state variable. So state, and here we are just turning off the lamp, turn off the lamp, and it will be printing out the output, and at the last line we are just updating the state again, and once we are done with it, we will just try to compile the code and see if it is working or not. So I will just name it as motion underscore lamp, and I will just save the code and try to verify it, and you can see it has compiled successfully. So it means we don't have any kind of syntax error or any issues with our code. So what I will do is I will just click on upload, and let's see the output of the code in action. So the code is finally uploaded. So let's open the serial monitor. So as you guys can see on the serial monitor, it has nothing printed on it. So let me just try to move my hand in front of the PIR sensor and see the output of it. And as you guys can see on the screen, that it has printed motion detected, and let's for 5 milliseconds, and you can see that it has print motion stopped. So it is working perfectly, and you can see also the relay module turned on when I put my hand in front of it. So let me show you it again, and you can see it is working perfectly fine. So let's try to connect the lamp with it and see the output in action. So finally I have connected the lamp with our smart socket and placed the PIR motion sensor on a box, so you can see on the screen, and I will just move my hand in front of it and it should turn on the lamp. So first of all, I will just open the serial monitor in here, and I will just put my hand in front of the PIR sensor and it should turn on the lamp for us. So let's see, and you can see I'm waving my hand in front of it and it has turned on the lamp for us. If I remove my hand from there, it should turn off the lamp, and if there is no motion for 5 seconds, it will turn off the lamp. And you can see on the screen it is working perfectly fine, and we are also getting the output on our serial monitor. So now you can see that it is too dark in my room and I have something on my table that I need to grab quickly. But what I need to do is, first of all, I need to turn on the lamp and then search for that thing. But using our motion detection based lamp, what we can do is we will just go in front of the desk and we will grab whatever we want from there, and we don't need to turn on the lamp, and it will automatically turn off the lamp after 5 seconds for us. So using it, we can save electricity, first of all, which is very expensive. Second of all, we can save our time, and third of all, we don't need to buy any expensive motion based lamp. We can create that on our own, and we can automate our home with the help of motion detection lamp. So we just need to wave our hand in front of it and we can do our thing, whatever we want to put on our desk or get something from our desk, and it will automatically turn off the lamp for us after 5 seconds. So isn't it exciting? So if you're liking the projects till now, you can let me know by messaging me. And that was it for this video. Let's move to the next video of the course. In this video of the course, we are going to be creating a smart lamp that can turn on automatically if a person is standing in front of it at a particular distance. Measure the distance between the person and the sensor that we are going to be using, which is a ultrasonic sensor that we are going to be using. This is the ultrasonic sensor, and you can see on the screen this is the ultrasonic sensor that we are going to be using to measure the distance between a particular person and our sensor, and we're going to be turning on the lamp according to that particular distance. In our case, we will be setting this distance to 15 centimeters. So if anyone is closer to this ultrasonic sensor in the range of 15 centimeters, so it will automatically turn on the lamp for us. So let's just try connecting it with our Arduino board. So you can see on the screen that it has 4 pins. I will just try to show you the pins. The first one is the ground, second one is the echo, third one is the trigger, and the last one is the 5 volt. So using the echo and trigger, it tries to send the data, and it tries to send a particular, which is a sound wave, and try to measure the distance as it receives that data. So basically it will transmit a sound signal, and it will receive that sound signal, and according to the time that it requires to get the signal back using the echo, it tries to determine the distance between the object. So we have a particular formula that we can use to find the distance. So we're going to be using that, and I will be also providing a PDF in which you can get in-depth knowledge of how this ultrasonic sensor works. So let's just try connecting it with our Arduino board. So I will just insert it into our breadboard first, and after that we will just connect the ground with the ground and the 5V with the 5V. So I will just connect the extensions directly to this particular pins. So let me just try to remove this both the 5V from our breadboard and reconnect it with the 5V of the ultrasonic sensor, and we will do the same for the ground as well. So the last pin is the ground pin, and now we will connect it. After that is connected, we will connect it to the trigger and the echo pin, and they will be connected on the pin 8 and pin 9 of the Arduino board. So we will connect the trigger pin on the pin 8 and the echo pin on the pin 9. So let me try to connect them first. I will just connect them with the Arduino first, and then I will insert that pin on the breadboard. So now we have successfully connected all the pins with our ultrasonic sensor, and you can see this is the output. I will be also providing the schematic diagram of how to connect it with the Arduino board in the resources section, so you can download it from there. So this is how you can connect it with the Arduino board. So after that we will just move to our computer screen and start writing the code for it. So let's move to our computer screen. So after coming to the computer screen, what we will do is we will just open a new sketch, and in that sketch we will try to define some new pins and try to control the ultrasonic sensor using it. So first of all we will just add two pins that will be the int trigger pin. So I will just type here trigger underscore pin, that will be equals to pin 8, and I will just recheck that I have connected it to the pin 8, and yes, I have connected the trigger pin with the pin 8, and we will be also defining the echo pin, echo underscore pin, and it is connected to the pin 9. So using the trigger pin, it is going to receive the data that it is going to be echoing through this echo pin. So basically it is going to send an sound wave, and once that sound wave touch the object in front of it and it bounce back to this trigger pin, at that time it will use a formula to calculate the distance between it. So the echo pin will send the data and it will receive the data. So after that what we will do is we will just define our relay pin. So I will just type here relay int relay 1, and the pin is connected with the digital 12 on the Arduino board. And after that we will just create two other variables as well. The first one will be distance, in which we are going to be calculating the distance and saving it in this variable. And after that we will be also creating a long variable with a long data type, and we will set it to duration, in which the sound wave duration will be stored. So after that, in the void setup, what we will do is we will just first of all initialize the serial monitor. So I will just type here serial dot begin, and we will add the baud rate to 9600, and we will add a semicolon. And in the next line what we will do is we will just add pin mode, and here we are going to be adding the trigger and echo pin. So first of all, I will just add the trigger pin here, and it will be set as an output. So I'll just type here output, and I will just close the brackets and add a semicolon, and we'll just try to add another pin mode for the echo. So I will just copy this echo from here, paste it in here. I'll add a comma, and it will be the input. And at the end of it, we will just add a semicolon. And we also need to provide the relay module as an output. So for that, first of all, I will just type here pin mode, and we will add the relay 1, add a comma, and set it to output, and we will add a semicolon at the end of it. So now we are done with the void setup. We will just move to our void loop and try to get the distance. So first of all, I will just type here digital, right? And inside that, we are going to be passing the trigger pin first. So I will just open my clipboard and just paste it in here, and I will set it to low. After that, I will just add a semicolon at the end of it. So after that, I will just try to add a comment here, so you will understand the algorithm that we are going to be using to measure the distance. So we are applying 0 volt to trigger pin, and in the next line what we will do is we will just provide a delay in microseconds, and we will provide a value of 2. So basically we are going to be providing a delay of 2 microseconds, or a pause of 2 microseconds, and just try to copy it in here and paste it. And after that, in the next line, we will just type digital write, and we will set the trigger pin to high. So I will just copy this line of code, and I will paste it in here, and we will be providing it as high. In this line of code, we are applying 5 volt to the trigger pin. So I will just try to copy it in here, the comment, and I will set it to 5 volt. And after that, what we will do is we will just provide a delay of 10 microseconds. So I will just copy this line of code, and I will just change it to 10. And now again, we will just set the trigger pin to low. So I will just open the clipboard and paste it in here, and I will also add the comment from the clipboard itself, and you can see. So this is the algorithm that we use to transmit the signal through our ultrasonic sensor. And now what we will do, we will go into a new line, and we will just type here duration equals to, and we will type pulse in, and it is in camel case. So the pulse is in lowercase, and the I of in is in uppercase. So just use the camel case in here, and we will just provide the echo pin, echo underscore pin, and we will set it to high. And we are going to be doing listen for echo, and this is a comment. I will just add it as a comment. And after that, in the next line, we will just calculate the distance by adding the formula. So I will just type here distance is equals to duration. I'll just correct the spelling of duration here, and we will divide it by 2, and we will add another bracket here, and again we are going to be dividing it by 29.1. and using this line of code, we are going to get the output in the form of centimeters. So we are going to be calculating the distance in centimeters. And after that, in the next line, we will just try to print out the distance on the serial monitor. So I will just type here serial dot print ln. I will add the brackets, semicolon, and I will just copy this line of code, so I don't need to type it again and again. So I will just type here distance, add a colon here, and it will print the distance on the serial monitor. And after that, in the next line, we will just paste that code, and we will just provide the distance here, which is calculated in this variable, and using this formula that we have written to calculate the distance in centimeters. And after that, we will add another print statement, and I will just add centimeters at the end of it. And if you want it to print on a single line, I will just remove the print ln from here, so it will print this entire thing on a single line. And after that, we will just try to save the code and see if it is working or not. So I will do distance underscore lamp, and after that I will just try to save it, and we will try to compile the code first by clicking on the verify button, and you can see it has done compiling successfully. Now we will just try to upload the code and see the output of it. So I have uploaded the code successfully now, and as you guys can see on the output screen that it is showing the distance in centimeters, and you can see it is showing the distance as 200 centimeters. So let me try to put my hand in front of it and see if the values changes. So you guys can see now it has reduced to 17 centimeters, and you can also see my hand in front of it, and I will just try to go more closer to it, and you can see that it is now showing as 12 centimeters. So you can see the distance with my hand and the ultrasonic sensor, so it means it is working perfectly fine. And now what we will do is we will just try to add an if statement and check for the distance below 15, and at that time we want to turn on the lamp or the relay. So for that first of all I will add an if statement in a new line, and I will just add distance is less than 15. At that time we want our relay module to be turned on, so I will just type here digital, right, and in here we will just provide our relay 1, and we will set it to low, so it will turn on the relay module with lamp. So I will just add a comment in here. I'll type turn on the lamp, and after that we will add an else statement, and I will just copy this digital right from here, and I will just type else. We want it to turn off the relay, so I will just add it in here, and after that I will just change it to high. The low will be replaced by high, and it will turn off the relay. And let's try saving the code and upload it onto our Arduino board and see the final output of it. So now our code has successfully uploaded onto our Arduino board. So let me try to put my hand in front of it and see if the relay module is turning on and off. So I'll just put it closer and even closer, and you can see that the relay module has turned on now, and it is turning on and off. And you can see the relay module has turned on if it is less than 15 centimeters. So let's try connecting a lamp with it and see the final output of it. And as you guys can see on the screen, the distance has reduced from 100 200 to directly 69 because the camera is placed in front of the ultrasonic sensor, and it is trying to detect the distance between the camera and the ultrasonic sensor. So now what we will do is I will just put this notepad in front of the ultrasonic sensor and see if it turns on when it is less than 15 centimeters. So I will just put that notepad in front of this camera. You can see on the camera as well, and I will take it near, and I will move closer to it, and I will make it less than 15 now, and you can see the lamp has turned on automatically without me giving it any input. It is controlling the lamp, and if I remove the notepad, it will turn off the lamp. So you can see now the lamp has turned off. and if I put it back in, you can see the lamp has turned on. So this is how we can create a distance based smart lamp with the help of ultrasonic sensor. So I hope you like this project. So that was it for this video. Let's move to the next video of the course. So in this section of the course, we are going to be creating a temperature based table fan using which we can control it with the help of our room temperature. So for example, your ideal room temperature is around 22 to 23 degrees Celsius, and after that you want to turn on a table fan that will reduce the heat in the room and give you fresh air with the help of that table fan. So basically we're going to building that in this video, so it will automatically turn on the table fan for us without our input by just getting the temperature from the room with the help of a DHT11 temperature sensor, and it will try to sense the environment, and according to the temperature it will control the table fan for us, and it will automatically turn on the table fan as soon as the temperature rises above the threshold value that we have set in our code. So for that, first of all, we need to connect our smart socket with our Arduino board, and after that we will be connecting our DHT11 sensor with our Arduino board. So let's just connect the smart socket first, and we will connect the table fan with our smart socket, and it will be controlling with the help of the relay. So you can see this is the socket which I am going to be using. So I will be leaving the schematic diagram for it in the resources section of this video, and it is exactly same as the connection for the smart bulb. So we are using the same adapter, the power pin, and we have just replaced the bulb holder with this socket, and we have connected the ends here, and we will be having two outputs of it, and we will be connecting it into the negative and the neutral of the relay module. So let's just try connecting it with the relay module. So once we have connected this smart plug with our relay module, what we will do is we will just connect our DHT11 sensor with the Arduino board. You can see on the screen, this is the DHT11 sensor, and it has 3 pins on it. You can see positive, negative, and out. And the out pin will be connected to the digital pin 2 of the Arduino board. So I will just take some jumper wires and connect it with the DHT11 sensor. So here are 3 jumper wires with me. We'll be just trying to connect it with the sensor. And once we are connected with it, we will insert the negative pin with the ground on the Arduino board and the positive pin with the 5 volt on the Arduino board, and the out will go into the pin 2 of the Arduino board, which will be the digital pin 2. So let's just try connecting it with our Arduino. So I have already extended connections of the 5 volt and the ground onto a breadboard, as you can see on the screen. So I will just connect it over there. So we have connected the DHT11 sensor with our Arduino board successfully. You can see here is the sensor, and we have connected it with the Arduino board. So now let's move to our computer screen and take a look at the code. So in the Arduino IDE, first of all, we need to install the library for DHT11. So for that, first of all, we will just click on Sketch, and here we will just hover over this include library, and we will click on this manage libraries. And here we can download the libraries that we are required. So here we can download the DHT11 library using which we can sense the temperature. So I will just type here DHT11, and we will get this result, which is DHT sensor library by Adafruit. So we just need to click on install. I have already installed it, so it is showing me installed. So you just need to click here on install, and it will install that current version of this library onto your system. And once we are done with it, we will just close this library manager, and we will click on these files again. And here if we hover over this examples, so you can see here are the different examples, which are some built-in examples and the libraries that we have installed, so we get the examples for the specific libraries. So you can see here is the DHT sensor library. So I will just open this DHT tester, and inside this program we will just do it full screen, and you can see here is some pins that are defined here, and we are using our DHT11 sensor. So you can see here is some DHT22. So I will just uncomment this part which is for DHT11. I will just comment it here for the DHT22, and we have connected our DHT sensor with the pin 2 previously. So here is the digital pin 2 which is defined for the DHT sensor, and if we scroll down, so you will be able to see the entire code. So this is the entire code for checking the temperature with the help of the DHT11 sensor. So I will just try to compile the code and see if it is working or not. So let's just check the syntax first by compiling it, and you can see compilation done. So it means we don't have any issues with it. And if we click on upload, so let's see if it is able to upload it onto our Arduino board, and it has uploaded it onto our Arduino board. Let's open the serial monitor to monitor the temperature in here. So you can see the humidity is 88%, the temperature is 25.20 in degrees Celsius and 77.36 in Fahrenheit. So here is the output that we get after uploading this code onto our Arduino board, and here are the different indexes that we get. So now what we will do is we will just close this serial monitor, and after that, and we will come here where we have defined the pins, and in here we are going to be defining int relay 1, which will be equals to pin 12, because we have connected our relay module with the pin 12 which is connected with our smart socket. So after that, in here we will go inside this void setup, and we will be defining the pin mode. So I will just type here pin mode, and inside here we are going to be doing relay 1 comma output, and I will just close this brackets. And after that we will go into the void loop, and inside this void loop we will just try to check for an if condition and set a threshold where we want to check the temperature. So let's just check current temperature right now in the serial monitor. I will just full screen it so you will be able to see. So I can see the temperature is around 25 degrees Celsius. So let's just take 25 as our threshold value. So I want my smart fan or my table fan to turn on if the temperature rises above 25 degrees Celsius, and if it rises above 25 degrees Celsius, I want to turn on my table fan, and if it goes below 25 degrees Celsius, I want to turn off the table fan. So now what I will do is I will just close this serial monitor, and we will just create some if conditions here. So let me just check the variables for the temperature that we are getting. So the H is for humidity, the T is for temperature, and F is for Fahrenheit. So let's just add the if statement after this line of code. I will type if T is greater than equals to 25.0, because the values are in float. You can see here is the float values that we have defined here in this code, and after that we will just check for this condition, and if this condition is true, at that time what I want to do is I want to turn on the fan for us. So I will just type digital write relay 1 low. So using this line of code, it will turn on the table fan, and similarly we will just check for the temperature below 25 degrees Celsius, and we will just turn off the fan. So let's just copy this line of code and paste it here again, and this time we will just replace this thing with a less. So if the temperature is less than 25.0, it will just turn off the relay by setting it to high, and it will turn off the table fan for us. So let me just try to save the code. Okay, it is showing that this sketch is read only, so I will click on OK and try to save it as smart underscore table fan. and we will just save this code, and you can see it has saved this code for us. I will just try to compile it first and see if there is any issues here. So I think I just missed a semicolon here after the pin mode. Let's just try to verify the code again, and it should verify the code for us. So you can see done compiling, and if we just try to upload the code, so let's just open the serial monitor, and you can see the current temperature is less than 25, which is around 24.8 and 24.70. So now what we will do is I will just connect the table fan with our smart socket, and I will just try to increase the temperature from 24 degree to 25 degree and see if the table fan turns on or not. So let me just do the connections and I will be back. On the screen, you can see that I have connected the table fan with our smart socket, and you can see the current temperature of the room is around 23.9 degrees Celsius. So we have set the threshold above 25 degrees Celsius. So what I will do is I will just try to put my thumb over the temperature sensor and try to increase the temperature with the help of my body heat. So I will just put my finger on the DHT11 sensor, and it will increase the temperature with the help of my body heat, and it should turn on the table fan for us. So let me just try to heat it up. And you can see the temperature is increasing as I have placed my thumb over the sensor, and you can see, and it has started the fan as you can see on the screen, and the fan is making a lot of noise. So I will just remove my thumb from here, and you can see the temperature is around 25.7 degrees Celsius, and the table fan has turned on, and I have just turned on the rotation of that table fan for me, so it will be giving the air towards my face, and you can see it is swinging now. So let's just try to decrease the temperature of the sensor. So I will just try to place a water bottle over this temperature sensor to reduce the temperature of it. And as you guys can see, I have placed my water bottle above the temperature sensor. So the water in my bottle is pretty cold. So it will reduce the temperature of the temperature sensor. And as you can see on the screen, it is now around 25.1. And if it goes below that, so it should turn off the table fan for us. So let's wait. And as you guys can see on the screen, the temperature has reduced below 24 degrees Celsius, and the table fan has turned off automatically. So we don't need to give it any kind of input to turn on the table fan or turn it off. It will automatically be controlled with the help of our temperature sensor that we have connected with our Arduino board. So I hope you find this project exciting, as we have created our own temperature based table fan with the help of our DHT11 sensor and the relay module with the help of our smart socket. So that was it for this video. Let's move to the next video of this course. So in this video of the course, we are going to be taking a look at how we can control a addressable RGB LED strip with the help of our Arduino board through our serial monitor, and change the color of the addressable RGB LED strip. So here is the RGB LED strip that I'm going to be using, and you can see this is the LED strip, and here are some connections which are connected to it, and it has in total 120 LEDs on this strip, which is of 2 meters, and you can find it on Amazon or any other shopping websites easily. And you can see on the screen, this is the model number of this RGB LED strip, which is addressable. So you can see here are some pins on it, and you can see I have soldered some wires with it, and there are in total 3 pins on this addressable RGB strip, which is first one is 5 volt, the second one is digital in, and third one is ground. So we are going to be connecting it with our Arduino board on the 5 volt and ground, and we are going to be connecting the digital pin with the pin 3. So let me just connect it with our Arduino board. So for connecting it with our Arduino board, I will need some jumper wires, and I will just connect it. Now I have successfully connected the RGB LED strip with our Arduino board, and you can see here is the final output of that. And once we are done with the connection, we will move to our computer screen and try to install the fast LED library and try to write the code to control the RGB LED strip with the help of the serial monitor. So let's move to our computer screen now. So once we are on our computer screen, we will just open a new file and I will just full screen it. And after that, we just need to click on this sketch and we need to hover over this include libraries. And after that, we will just click on manage libraries and it will open the library manager for us. And after that, we just need to search here fast LED. So I will just type here fast LED. And you will get this first result that will be fast LED by Daniel, and you just need to click on install and it will install it onto your system. It is showing me to update the library, so I will just update it by clicking on update and it should update it onto the system. And you can see I am using the latest version of this fast LED library now. So after that, we will just close this library manager. So once we are done with it, we will just add some header files. So I will just add a new line and in here we will just type hash include. And inside that we are going to be providing the fast LED.h. So I will just type it in here fast LED.h. And in the new line we will just type hash define LED underscore pin, and this will be the digital pin that we have connected from our RGB LED strip to the Arduino board. So in our case, we have connected it on the pin 3 of our Arduino board. And after that, in the next line, we will just type hash define number of LEDs. So I will just type num underscore LEDs, and it will be 120 in our case because we have a 2-meter LED strip and it has in total 120 LEDs on it. And after that, in the next line, we also need to create the array of these LEDs that we are using. So we need to create this array of 120 LEDs here. So I will just type here C RGB and I will just type here LEDs, and in square brackets I will just pass the num underscore LEDs and we will add a semicolon at the end of it. So this is the array that we have created and we can call it anywhere in our program. So it will be referring to all the LEDs, which are in total 120 LEDs in our case, and it will be controlling them. So once we are done with it, we will just move to the void setup, and in here we will just type fast LED dot add LEDs, and these are all the built-in function of the fast LED that we are using. So basically this library has all these built-in functions that we can use. So inside this bracket, we just need to pass the model number of our LED strip. So in our case, it is WS2812B. And after that, we will add a comma, and then we are going to be providing the digital pin in here. So I will just type LED underscore pin. And after that, and at the end of it, we are going to be setting the scheme which we want to use. So in our case, we are going to be doing it RGB. And after that, we will just come outside this bracket and we will add some round brackets here. And in here, we're going to be providing the arrays of LEDs that we have created. So you can see I'm just providing this LEDs, comma, num underscore LED. And after that, at the end of it, I will just add a semicolon. And once we are done with that, we will move to the next line and we will just try to add a safety feature in here by setting the voltage to 5 volt and the milliamps to 500. So I will just do fast LED dot set max power in volts and milliamps, and I will just provide 5 and 500 in here. So it will just cap this voltage at 5 volts and 500 milliamps. And after that, in the next line, we will just do fast LED dot clear, and the C should be in small. And after that, we will just call this function and add a semicolon at the end of it, and we will do fast LED dot show, and we will add a semicolon at the end of it. So once we are done with it, we will move to our while loop, and inside that we are going to be using a for loop to control the RGB LED strips for us. So in here I will just add a new line and type here for, and inside that we are going to be declaring a int I that will be equals to 0. We'll add a semicolon, and I will type I is less than num underscore LEDs, and we will do I plus plus, so it will be incrementing the for loop for us. And inside this for loop we're going to be trying to change the color of the LEDs. So in here I will do LED, and in square brackets I will just provide the current LED with the help of I, and we will do equals to, and we are going to be using the array that we have made. So I will do CRGB, and after that I will just provide 2 colons here, and I will just set the color to red and add a semicolon at the end of it. And to show the result, we just need to type fast LED dot show, and the S for the show should be in small, and we'll add this brackets in here. And once we are done with it, we can also add a delay, so we will be able to see the output. So it will turn on all the LEDs one by one with this amount of delay. So once we are done with it, we will just try to save the code, and I will just name it as RGB underscore LED underscore control, and I will just try to save the code. After that, we will just try to compile the code by clicking on verify and see if we get any kind of error. So I think there is some error here, so I just need to set it to LEDs. I just missed the S in here, so let's just try to verify it again, and this time it should verify it successfully. You can see done compiling, and let's just try to upload it onto our Arduino board and see the output of it. So as you guys can see on the screen, we have set it to red, but it is turning the LEDs to green. So to overcome that, what we will do is we will just change this thing RGB to GRB. I will just set it to G, and if we save the code and if we upload the code onto our Arduino, it should fix the problem. And you can see now the LEDs are turning red one by one after 5 millisecond delay. So if you want to turn the entire LED strip to red without any delay, so we just need to comment out this line of code where we have set the delay, and if we try to upload it onto our Arduino, it should change the color of the LEDs, and you can see the entire LED strip is now red. And if we want to change the color to something else like green, so I will just type here green, and the G will be capital. I'll just try to save the code and upload it onto our Arduino. It should turn the LED strip to green, and you can see the output on the screen. Let's just try with blue, and if I save it and try to upload, it should turn the LED strip to blue. So now we have seen how we can change the color of the RGB LED strip. But now what we want to do is we want to take the input from the user through the serial monitor and try to control the color of that RGB LED strip. So for that, we just need to create some if statement and add that for statement in that. So for that, first of all, we need to take an input from the user through the serial monitor. So we will here add an character input, and inside the void setup we will just do serial begin serial dot begin, and we will set the baud rate to 9600, add a semicolon at the end of it, and inside the void loop we will do input equals to serial dot read, and we will get the input from the user, and we can also print it out so the user will be able to see that what input was given. Serial dot print, and we will just print out the input in here. So once we get the input, we will just check for the conditions. So now I will just check for if the input is equals to R. At that time, what I want to do is, so I want to change the RGB LED strip color to red. So I will just try to close this if statement in here, and I will just change the color to red. And the R for the red will be capital, and the first letter of every color will be capital. So just keep that in mind. And once we are done with it, we will just copy this entire piece of code and make few more copies of it. So in here we will just check for green, and for green I will just set the input to G, which will be a capital G. In the next line we'll just check for blue color, and I'll set it to blue. For now we will just add 3 color inputs. If you want, you can add multiple color inputs in here, and we will just try to save the code and upload it onto our Arduino board. And once we have uploaded the code, the RGB LED strip is turned off. So now we will just open our serial monitor, and in here we're going to be just providing the input. So let's just try changing the color of the RGB LED strip to red by typing R, and you can see now the RGB LED strip has turned to red. Let's just try turning it to blue, and at last green. So you can see it is working perfectly fine, and we are able to control our RGB LED strip with the help of our serial monitor. So that was it for this video. Let's move to the next video of this course. So in this section of the course, we will take a look at how we can make a Telegeram bot that can control our Arduino using an API, and it will be using a bot that we can use to control all our Arduino components that are connected with it. So particularly in this video, we will take a look at how we can make the Telegeram bot, and in the next video, we will integrate it with our Arduino board. So it will be creating a IoT based home automation system for us with the help of the Telegeram bot and the Arduino. So we can control all the devices that are connected with our Arduino board through the internet with the help of our Telegeram bot, and it will be making it fully fledged IoT project that we can use to automate the things in our home with the help of the Telegeram bot and the Arduino Uno board. And you can control the devices from all over the world, so you don't need to be at your computer system and try to give the input through your serial monitor. So you just need to open the Telegeram bot and send any command that you want to use, and you can control all the devices that are connected with your Arduino board. So for that, first of all, you will just open our Ultimate Home Automation folder in which we have all the files, and I will just open the VS Code IDE in here. Now after opening that, I will just create a new file, and we will just name it as telebot ARD for Arduino. I will just type .py. So we are going to be using Python to write this Telegeram bot, and we will be trying to integrate this Python code with our Arduino board. So I will just save this file, and you can see here is the file that we have created, that is telebot ARD, which stands for Arduino Telegeram Arduino bot. And after that, I will just select my Python interpreter to 3.6.2, which I have already installed on my system. And once we are done with it, I will just open my Telegram on my browser, And after logging into my Telegram account, you just need to scan a QR code and it will be able to log in into your web Telegram account. And after that, we will just search here for bot father and you will find this result here. So I will just click on it and you can see this is a bot father using which we can create different bots for our Telegram, and we can use them with the help of our Python code. So for connecting it with our Python code, we need to install a library called telepot. So here is the documentation of that particular library that we are going to be using, which is telepot. So I just need to copy this command to install it onto my system. So I will just copy this command and I will just open my CMD as an administrator. I'll just click on administrator and give it the administrator permissions, and after that it should launch the CMD. And after that I will just try to paste this piece of code to install it using the pip package manager. So I will just type pip install telepot and it should start installing it onto my system. It will take few seconds to install it onto my system, and you can see it has installed it successfully onto my system. So once we are done with it, we will just create a Telegram bot which we will be using to control the Arduino. So for that I will just move back to the Telegram bot father, and here we will just add /help. So it will open the help for this Telegram bot API. So you can see we just need to type /bot and it will create a new bot for us. So I will just type /bot. So as you can see, it has replied us, all right, a new bot. How we are going to call it? Please choose a name for your bot. So we just need to type the name of our bot in here. So I will just name it as Telebot ARD and I will hit enter. Okay, so you can see it is telling us that good. Now let's choose a username for your bot. It must end in bot like this, and this is the example. So I will just type in here tele_ard_bot. So this will be the username of our bot and we will be calling it as telebot ARD. And you can see it has done. Congratulations on your new bot. You will find it at, and this is the address where we can find our bot. And now we can add the description and the profile picture of our bot. So for now we will just use this token API and we will just copy it. It will be used in our Python code to control this bot for us. So once we are done with it, we will just minimize this thing, and in our Python code we will just try to import the library which we have installed. So I will just type here import telepot, and after that in the next line we will be creating a function. So I will just name it as telepot ARD, and inside this we are going to be passing a message that we will be getting from our user through the Telegram. And after that in the next line we will just take the username of the particular user that we are getting the message from. So I will just set it to user name equals to message, and inside that we are going to be adding in single quotes from. After that we are going to be adding another brackets in here, and here we will take the first name of that user who is sending us the message. So I will just type here first_name, and after that we will be just concatenating it with a blank string here, and again we will just add the last name. So I will do message, and after that in brackets we will just provide from, and we will provide the last name of that particular person. So I will do last_name. And if you want to get more knowledge about it and how to use the API, you can just go to this documentation link. I will leave it in the description of this video or the resources section, so you can just check it out and you can get a lot more details about this API that we are using. I will be just using a basic code using which we can just send and receive the messages with the help of our bot. And after that in the next line what we will do is we will just add this piece of line from here. I will just click on send message. After that we will just copy this line of code that we have here. So using it we can just get the type of content, chat type and chat ID of that particular person that is sending us the message. So I will just paste it in here, and after that in the next line what we will do is we will just create an if statement, and in that if statement we will just check for the content type. If the content type is in the form of text, then we will try to add some if conditions in here. So I will just type content type equals to, and in the single quotes I will type text, and if it is true, then in the next line we will add some few more lines of command. We will just type command equals to message. So this message will be the command to our Telegram bot. So that's why we are creating this particular variable where we are saving this text that we have received from the user. So after that in the next line we will just type print, and in here we will just add got command, and we will just try to print it out on our screen. So I will just try to add a string in here. So our command is in the form of string, so I will just do %s, and we will add another percentage symbol in here, and we will do command. So it will print it out on our terminal, and after that inside this if statement itself we will do another if statement, and we will just check for if the input from the user is hello. At that time we want to do in command. So if hello is in the command, that time we want to send the message to the user. So let's just try to open the documentation first, and let's see how we can send a message. So you can see here is the format using which we can send a message to the user. So using this line of code we can send the message to the user, and we will just copy it and we will just try to paste it in our code. So I will just paste it in here, and we also need to create this variable that is bot. So I will just try to create that first. We will just go outside our function, and in here we will just create a variable named bot that will be equals to telebot dot bot, and the B will be capital this time, and inside that we are going to be providing the API key or the credential for our Telegram bot which we have created using the bot father. So I will just go back to the Telegram, and I will just try to copy it from here, and after that we will just try to paste it inside the single quotes, and you can see now the error has removed from here. So after that we are going to be replying to the user with some kind of message. So using this line of code it will just send the same message that user has sent. So if I will send hello, so the bot will repeat that again and again, but we want to send a different message to the user, so I will just remove that, and in here in double quotes I will just write some message. So I will just type hello, this is ready bot for Arduino Uno. How can I help you? How can I help you? So we will be asking our user this question if there is a hello inside the command, or we can also set it to help if you want, but for now we will just type hello, and this should be the output that we get through our chatbot. So once we are done with it, we will go outside our function, and after this bot API we will just add bot dot message underscore loop, and inside that we are going to be adding the name of our bot, that is telebot ARD, and we will add a while loop in here. So it will run the code again and again and check for the input from the user. So if we don't add this while loop, it will get terminated as soon as we run the code. So we need to add this while loop in here, and we also need to import another library that will be time. So we are going to be providing it a sleep. So I will just import the time library, and inside this while loop we will do time dot sleep, and we will provide a sleep of 20 in here, and after that we will just try to save the code, and if we try to run the code, so it should start our bot for us, and I think it has started the bot for us. So let's just try opening our Telegram, and going to the URL of our bot, which is this teleard_bot, and you can see here is our bot. So in here, let's just try providing a command as hello. So you can see we have got a reply from our bot, which is hello, this is Telebot for Arduino Uno, how can I help you? So similarly, we can add a number of inputs in here. So for example, I will just try to add another statement in here. So I will just try to copy this line of code, and we will add another command in here. So if I type here help, so it should ask us hello, how can I help you? And you can see also we got the command that we received from the user. So we have just typed hello, so it got that command in here, and you can see it has printed it on our screen. So let me just try to close this, and let's just try adding the username as well. So I will just provide here %s, and after that outside here we are going to be adding %, and we will provide the username in here. So I will just type username, and if we save the code and if we try to run it again, so this time it should also print our username. So if we just type help in our chatbot, it should provide hello and our username and how can I help you. So let's just try opening our bot in here, and I will just type here help, and you can see it has printed hello Arbaz Khan, how can I help you? So in this way you can add different commands into it. And if you want to get more knowledge about this Telegram bot API, you can just refer this page that I have mentioned in the description of this video. So you can just check it out, and you can add a number of features into it, and you can just go through it. You can see it is a huge documentation with different commands and different features that we can add into our bot. So if you want to add multiple features into your bot, you can just refer this. So that was it for this video. In the next video, we are going to be integrating this chatbot with our Arduino board. So without further ado, let's move to the next video of this course. In this video of the course, we are going to be taking a look at how we can control a LED light which is connected to our Arduino board with the help of our Python code. And in the next video, we will integrate this code with our Telegeram bot code, using which we can control components that are connected with our Arduino board with the help of the chatbot we have created with the help of Python and Telegram. So for that, first of all, I will just connect this red LED with our Arduino board on pin 12, and after that we will just try to write the code in Python using which we can control this LED light with the help of the user command. So now I will just connect this LED with our Arduino board, and the positive pin will go into the pin 12 of Arduino, and the negative will go into the ground. And after connecting that, I will just connect the USB cable with our computer. And we have successfully connected the LED with our Arduino board. So now we will move to our computer screen and write down the Python code to control this LED with the help of the serial library. So let's move to our computer screen now. So inside the VS Code IDE, we will just create a new file, and I will save it with the name Python Arduino Control. Python ARD control.py, and I will just set it to all files and save it in here. Before controlling the Arduino with the help of Python, we need to install a serial library. So for that, we will just open the documentation of the PySerial library. So we are going to be using this PySerial, and after coming to this page, I will just click on install, and we will just copy this line of code to install it onto our system. So I will just open my CMD in here, and we will just try to paste the command in here. And after pasting the code, I will just hit enter, and it will try to install it onto my system, and it shows that I have already installed this PySerial on my system. So once we are done with it, we will just minimize this CMD, and we will just go through the documentation in here, and we will just click on this open serial port. So basically we are going to be using the serial monitor to just give the command, but we are going to be using our Python code which will be sending the command to our serial monitor. So you can see here is the code snippet that we can use and refer to create our own code using which we can control the Arduino board. I can see we can just import this library, and we just need to set the COM port of the Arduino board. So I will just try to copy this line of code from here, these two lines of code, and we will go into our VS Code, and in here we will just try to paste it, and I will just remove this thing from here, and we will just open our Arduino IDE, and we will just try to upload the code using which we can control the LED with the help of the user command. In the Arduino IDE, I will just click on files, and I will just search for the input LED control. And after that, we will just upload this code onto our Arduino board. After uploading this code, we will go back to our Python code, and inside there, we are going to be just changing the COM port. So I will just check my COM port in here. So let me just try to check the COM port which we have connected with. So it is the COM3. So I will just close this program now, and we will set this to COM3. And this is the port where our Arduino board is connected. And after providing that, you also need to add the baud rate in here. So I will just add a comma, and we will just provide 9600, which is our baud rate which we have set in our code. So if I just open our code, so you will be able to see that we have set our baud rate to 9600. So we are going to be using the same baud rate and try to pass the serial input with the help of our Python code. And once we are done with it, in the next line, we will just try to print. Inside that, we're going to be typing press 1 to turn on the LED, and I will slash n here, and we'll do the same. But this time we'll ask for 0 input, and if input is not 0, we'll just turn on the LED. And we can also just remove this thing from here, and I will just set it to input, which will be equals to input, and I think I should name it something different. So I will do input underscore user, and this will be the input which will be stored inside this input user, and it will also print out press 1 to turn on the LED and press 0 to turn off the LED. And after that, according to the user input, we are going to be controlling the LED which is connected to the pin 12 on our Arduino board. And already we have uploaded our previous code which was used to control the LED which is connected on the pin 12 with the help of the serial monitor. So the previous code which we have written was not working properly because of zeros and ones. And now what I have done is I have just created a while true loop, and inside that I am taking the user input, and this loop will run again and again, and the user input has been changed to y and n, and you can see we are checking for the condition if the input underscore user is equals to y, and serial dot write, we are going to be turning on the LED which is connected on pin 12. And similarly, we are just turning it off with the input n. So if we just try to run the code, and if I just try to press y, it should turn on the LED, you can see on the screen. And if I just press n, so it should turn off the LED for us. So this is how you can control a LED with the help of our Python code PySerial library. So if you have any doubts or issues regarding it, you can let me know in the Q&A session of the course. So let's move to the next video of the course, in which we are going to be integrating this both piece of code that we have written, the Telebot as well as Python Arduino control together, and try to control the LED with the help of our Telegeram bot. So let's move to the next video of this course. So in this video of the course, we are going to be integrating the Python Arduino control as well as the Telegeram bot together and try to control our LED which is connected on the pin 12 with our Arduino board with the help of our Telegeram bot. So for that, we will just copy these two lines of code from here, and we will just try to paste it inside our Telegeram Arduino bot after this line of code. And I will just try to paste it in here. And after that, we're going to be creating two more if statement inside this Telegeram bot Arduino function. So after this line of code where we have the help command, we will just add if LED on in command. At that time, we will just turn on the LED which is connected on the pin 12 of our Arduino board. So I will just copy this line of code from here, and we will just try to paste it inside this if statement that we have created. So I will just type it in here. And similarly, we will add the same if statement in here, and we will just try to turn it off, paste it in here, and I will just type here off, and we will send n in here. So if I just try to save the code now, and you can see we have added this 4 lines of code in our Telegeram bot ARD. And now if we just try to save the code and try to run the code, it should be able to control the LED for us. So now we will just open our Telegram bot in here and we will just try to send the commands. So let's just try LED on, and you can see on the screen the LED is turned off right now. So let's just try sending this command and see if it is turning on the LED or not. And you can see the LED has turned on as soon as we have sent the command in real time, and we will just try to turn it off now. And you can see everything is working in real time with no delay, and you can see it has turned off. So let's just try turning it on again in real time. LED on, and you can see it has turned on in real time. There is not a single second delay with this process. So let's just try turning it off again. And finally, we have built our IoT project that we can control from all over the world. This Telegram bot can control all the components that are connected with our Arduino board with just a single command and without any kind of delay. And it is working in real time with the help of our Arduino board and the Python code that we have written. And if you will just stop this code and try to send any command, it will not work at all, because whenever our code is running in the background, which is our Python code, at that time only it will be able to run these commands onto our Arduino board. So if I just try to provide hello right now, so you can see it is not replying to me anything. But as soon as we will just run the code in Python and try to control it, and you can see it has now sent the reply as soon as we run the code. So let me just try to turn on the LED again, and you can see now it is working. So using this Telegram bot, you can connect n number of devices with your Arduino board and try to control them from all over the world without any kind of delay, and it will be working in real time. So that was it for this section. If you have any doubts or issues regarding it, you can let me know in the Q&A session of the course. So without further ado, let's move to the next section of this course. In this section of the course, we are going to be trying to control our smart devices with the help of our Jarvis AI voice assistant with the help of voice commands. So in this particular video, we will just try to control the LED which is connected on the pin 12 of our Arduino board. So for that, first of all, we will just open our input LED control code, using which we can control the LED with the help of the serial monitor. So we are going to be just uploading this code onto our Arduino board. And after that, we will just open the serial monitor and try to control the LED and see if it is working or not. And as you guys can see on the screen, it is working perfectly fine. So after that, we will just close this serial monitor and we will go back into our Python code. So after that, in the resources section of this video, you will find this jarvis.py file with this entire code, as well as I will add a link to a video. With the help of that video, you will be able to create your own Jarvis AI voice assistant. So after doing that, we will just open this jarvis.py file. We are going to be using our Python Arduino control code. So I will just copy these two lines of code, using which we are going to be sending the serial input with the help of this two lines of code to our Arduino board. So I will just come inside here, and in this imports, I will just import these two things, which is the import serial, and we are going to be defining the port at which the Arduino board is connected, as well as the baud rate. And once we are done with it, we will go to the end of this code on the line 337. And in here, we will just try to add another elif statement. So what I will do is I will just add few spaces in here, and I will type L if LED on in query. At that time, what I want to do is I want to turn on the LED which is connected to our pin 12 on the Arduino board. So we will go back to our Python Arduino control code, and we will just try to copy this line of code, using which we can just turn on the LED. So I will just copy it and paste it in here. And similarly, I will make a duplicate copy of the same code, and we will just try to turn off the LED as well. So I will just replace the on with off, and the data which we are going to be sending this time will be N to turn off the LED. And we will just add an space in here. So after that, we will just try to save our code, and if we run our code, it should be able to control the LED which is connected on the pin 12 on our Arduino board with the help of our Jarvis voice assistant. So let's see this in action. So before running the code, what I will do is I will just skip it as on and off only. So we have only one LED connected with our Arduino board. So for now we will just set it to on and off only. And if I just try to save the code and if we try to run the code, it should try to control our LED. Jarvis, turn on the LED. So as you guys can see on the screen, it has turned on the LED for us. And if I try to give it a command as turn off the LED Jarvis, so it will turn off the LED for us. So you can see on the output screen that it has turned off the LED with the help of our voice commands. So if you want to add a response from Jarvis, so we can just type in here speak, and in here we will type OK. So turning off the LED. If I just try to do the same for turning off the LED, in this statement we will do turn on, and here it is going to turn off the LED. So it will speak this thing for us whenever we give this command. So let's just try this thing as well. Jarvis, turn on the LED.
Okay, sir. Turning on the LED.
Okay, it's telling it as LED. So I will just add some spaces in here. So it will tell it as LED. Jarvis, turn on the LED.
Okay, sir. Turning on the LED.
Jarvis, turn off the LED.
Okay, sir. Turning off the LED.
And you can see it is working perfectly fine. So let me just try to stop this program. So you will find the entire code in the resources section of this video. So you can go there and download this file and try it yourself. So that was it for this video. Let's move to the next video of the course. So in the previous video of the course, we have seen how we can control the LED which is connected on the pin 12 of our Arduino board with the help of our Jarvis AI assistant with voice commands. So we were able to control the LED with the voice command. So as soon as we say turn on the LED, so it was turning on the LED for us, and as soon as we say turn off the LED, it was able to turn off the LED for us. So in this particular video, we will try to control different appliances with our Jarvis AI assistant and try to control them with the help of the voice commands. So first of all, we need to connect the relay module and create a smart socket to control or to connect our appliances with our Arduino board. So let me show you the connection of the smart socket first. So in this section of the course, we will try to create a smart socket with the help of the relay module. So you can see this is the socket which I am going to be using, and whatever we will plug into this smart socket, it will become a smart plug with the help of it. So I will be leaving the schematic diagram for it in the resources section of this video, and it is exactly same as the connection for the smart bulb. So we are using the same adapter, the power pin, and we have just replaced the bulb holder with this socket, and we have connected the ends here, and we will be having two outputs of it, and we will be connecting it into the negative and the neutral of the relay module. So let's just try connecting it with the relay module. So once we have connected this smart plug with our relay module, we will move to our computer screen. So after coming to the computer screen, first of all, what we are going to be doing is we are going to be trying to control the lamp using our Jarvis AI voice assistant. So for that, in the code, we are going to be making some changes. So you can see we have here an elif statement which says on. So we have here a reply that okay sir, turning on the LED. So we will replace it with lamp, because we're going to be controlling the lamp, and we will do the same here. Also, we need to change the input, because as we know, the relay module uses the inverted or the opposite output to turn on the relay and turn off the relay. So we will just set it to N to turn off the relay, and we will set it to Y when we want to turn off the relay. So whenever we want to turn on the relay, we will just pass N, and whenever we want to turn off the relay, we will just pass Y. And using this piece of code, we will be able to control the smart socket and try to control our lamp which is connected with our smart socket. So let me just try to save the code, and let's try to see the code in action now. So as you guys can see on the screen, right now the lamp is off. So let me try to run the code and try to give it a command to turn on the lamp for us. So let's see. So I just need to do one correction here. You can see that I have misspelled the spelling of lamp. So I will just change it to lamp again. And we will try to save the code. And if we try to run the code, Jarvis, turn on the lamp.
Okay, sir. Turning on the lamp.
Jarvis, turn off lamp.
Okay, sir. Turning off the lamp.
So as you guys can see that it is able to control the lamp with the voice command with the help of our Jarvis AI voice assistant. So now we will just try to connect the table fan and try to control that as well. So let me just try to connect the table fan with our smart socket once. So now as you guys can see on the screen that I have connected the table fan with our smart socket, and we will just replace this lamp with the fan. So I will just do it as table fan, and we will do the same to turn off the fan. At that time also it should tell us, okay sir, turning off the fan or the table fan. So I will just add it in here, and if we just try to save the code and if we try to run it, so let's see the output of it. Jarvis, turn on fan.
Okay, sir. Turning on the table fan.
So as you guys can see on the screen that table fan has turned on as we give it a command to turn on the table fan. Let's just try to turn off the table fan with the help of our voice command. Jarvis, turn off fan.
Okay, sir. Turning off the table fan.
And as you guys can see, the table fan has turned off as we have given the command to turn off the table fan. So this is how you can control different appliances that are connected to our smart socket with the help of our Jarvis AI voice assistant with the voice commands. And all the devices that you can connect to the smart socket will convert into smart devices, and you can control them with the voice commands with the help of our Jarvis AI voice assistant. So that was it for this video. Let's move to the next video of this course. So finally we have reached to the end of our course, and I hope you have learned a lot of features of the Jarvis AI assistant and how you can develop them on your own, get a brief idea of how you can add your own features into it. If you have any doubts or issues regarding it, you can message me and I will try to help you out with that. So I hope you like the course. Thanks for watching the course. I will see you in the next one. Bye bye.